for the sake of space. I'm going to get these out of our way. No, it's okay. Whoops. That's interesting. I'm going to just leave that. Otherwise, it's going to be worse. Thank you. Yeah.
Standing out here for a while and we didn't.
I'm sorry.
Well, we didn't know we had to push the button.
Good morning. Here
Good
you
morning.
Go.
Sorry, we're late.
It's okay. No, you're on time. We figure, hey, with the weather, people are going to be a little late. That's fine by us. Come on in. Here you go. Just need you guys sign in and then.
I'm registered. He's auditing. I just called yesterday, so he's
That's
not
fine.
any hardware or anything.
That's fine. Cool. There's your enormous box for not so much hardware.
Okay.
Huh? So Leah
Leah from.
Do you? Yeah.
Yeah.
This is her third time working with processing in a week.
Wow. You're not here for this.
Yeah, she is. She's going to hang out with us.
Wow.
I don't know when he's processing, so I figured I'd know.
Kool-Aid for everyone. So we're terrible about it.
About what?
The processing flavored Kool-Aid.
I feel like Brian makes fun of us, and
I know, but look at this. Right? On a snow day.
yeah.
I know he makes fun of us. It's the glue that holds everything together.
I feel like it's my answer for everything, but it's not everybody's.
Nobody has put forth anything that's as broad spectrum that I've seen. I don't know. I could be wrong. I mean, I think if you're really conversant in Java
You could do it with Java.
and really conversant in Python, you could probably do it.
But with the ease.
Right, with the ease is the thing. So,
I mean, like the sketch in there. It was like 15 minutes.
speaking of which, I'm going to pull some example stuff.
Okay. Oh. Where's the laser button? Yes, ma'am.
I'd like your password to get on the.
So it's SparkFun, all lowercase, 6175. It's kind of hidden by other scribbles. Yep. So also, while we're kind of waiting for the last few people, if you can scribble down the URL here, it's actually for this presentation. I make my presentations kind of like more of a reference document than an actual presentation. So the day will roughly follow this presentation, but it gives a lot of reference and example code and great information for you to reference after everything we've talked about has fallen out through your ear. So if you snag that, it's going to be useful to you. And actually, in here is a notebook for you, too. So in your boxes, you have the makey hardware stuff, but there's also a graph paper notebook for you that's going to be super useful as we get into, because we have to deal with the Cartesian grid system and graphing and all that fun stuff. So there are notebooks in there for you. Yep. So open the wonderful big present that doesn't have a lot of big stuff in it.
I was just going to get a key, but that works.
There you go. I'll be able to open from there.
That one actually comes with a plastic body also. So you can, there's a more lightweight version of it. But I like the metal body for spider tail. There's a little spider symbol that's on it. Your outlets are cool.
So did you have to wear your snowshoes to get here? Diagonal coming from Longmont. There's like one lane plowed. Like you could tell the plow was like just out of eyesight for me. There's one lane, the other lane's all chunky.
Both lanes are clear, but you could have an issue where 2 cars going really slow and then 10 cars going to pass them all, but the 2 cars going slow.
Yeah. We'll get started. So we're going to get started.
You're cool.
I'm good. Yes, Gruson said I'm cool.
You are cool.
Well, that goes without saying.
So my name's Derek. This is Jeff, both from SparkFun, and we also have Angela with us. She's a educational outreach coordinator as well, just like Jeff. I'm the curriculum curator here at SparkFun. So I work with teachers and create materials for teachers, and I get to kind of play with our stuff and figure out how to get in a classroom. And we'll actually see some of that stuff later on today. I'd like to thank you for being here on not the greatest weather of a morning and braving the elements to get here. So, processing. And first off, I want to get to know you guys a little bit. You know, we've kind of talked as we've shown up, but I want to go around, kind of get your name and why are you taking this class? Why are you interested in processing? So, we'll start here.
I'm Jill Cross. I teach high school and kind of took on the challenge of creating an entire programming department and curriculum. So I'm just taking as much as I can and deciding how I'm going to teach each class next year.
Nice.
I'm Leslie Trexler, and I'm from Adams County District 12. I'm a teacher, and I'm going to try to teach my kids.
I'm David Williams. I'm just a resident of Longmont, working as an engineer. I'm actually down here to figure out how to reteach this class at the Tinkermill Hackerspace in Longmont.
Ah, nice.
In fact, Lindsay's in here now.
You've been sent.
I'm Scott. I'm a professional.
Nice.
I've been through. I just like learning.
Okay.
I was a teacher once. So I did classes.
Cool. I'd really like to, as we go through the day, I'd really like to pick your brain on your opinion of processing as we go through it. So.
We got a PhD computer science facility.
Okay.
I'm going to get a little bit more.
That's okay.
My name is Val. I work in IT, and I've always been interested in interactions between the real world and electronics and physical creation.
Perfect.
Good morning, I'm Adam. I'm here now. I've done a lot of organic projects in the past that have been high, and I've made some visualization happen by writing apps and stuff to complement organic, but I think it would be a much better integration and lighter efficiencies in the process. So here to figure out how to add a little bit of visualization practice.
Perfect. I'm going to go back here and then I'll come to you. Dan.
So I'm Kerry. I'm an hobbyist, and I've done quite a bit of embedded projects using the here on my computer. Started working on building custom.
Okay.
And I'm taking this class because I want to bridge that gap between PC and hardware and getting easier on-screen controls running anywhere.
Perfect. And yeah, go ahead.
I'm Eric Reed. I'm a senior at Runberg High School, and I'm just going to learn.
You will learn a lot.
Hi, I'm Leah. Teaching art classes at University of Denver. Actually working in sculpture classes. They're making artwork interactive.
This is
I'm
her.
going to be part of a ton of professional courses, so I'm pretty prepared.
It's your third processing workshop in a week. So Leah's been here a lot. She's been through it. So I think you're going to do just fine. So Jeff, introduce yourself.
So I'm Jeff Branson, and I work here at SparkFun as an educational outreach coordinator. A lot of my time is spent traveling and teaching Arduino and processing and a bunch of other stuff. I'm a confirmed processing junkie. I use it a ton. In fact, my adoration of processing is a subject of mockery here at SparkFun. So I hope I can be of assistance today, but we find that these classes a lot of the time very flat learning environments.
Great. My experience with processing, I started writing. I hadn't written a single line of code until when did we meet? 2 years ago? 3 years ago. So I started in Arduino, so I'm an Arduino native in terms of code, not only code, but also electronics. And Jeff actually showed up in my classroom when I was a teacher, did 40 minutes of processing, and I got hooked. And through a stream of emails between me and Jeff, started to create a lot of curriculum material around processing because I saw the strength of it, getting kids to write code before they jump into embedded electronics with Arduino. Because when you have two things that they're learning, circuits and code, you start running into problems of how do I troubleshoot this as a teacher? So I saw processing as that. And then it's just kind of ballooned beyond that. Jeff mentioned being made fun of because we're processing junkies. I don't know. You want to rock, paper, scissors over who's more of a junkie? Right. So we'll get right into it. So a little bit of housekeeping for today. Donuts, etc. Breakfast stuff's over here. There's coffee out in the break room. Restrooms are just out in the hallway here, and kind of you jog a little bit to the left. And then lunch, we're planning on breaking at about noonish for lunch, and we're going to give you an hour on your own. There's plenty of places around here that you can go grab food, or if you brought something, feel free to hang out with us for the hour. Go for it.
Really briefly, this class is advertised to go till 5 o'clock. Derek and I have talked about this. We feel like after about 6 hours, people get right up to about here.
We want to open the last 2 hours of the class up to guided free swim, where if you have a specific application or you see something that you want to do in processing, after about 3 or 3:30, we're going to open this class up and let you do some experimentation. If you want to pick our brains, we're here for that. If you want to borrow some hardware and interface that with processing, we can make that happen. But we want to give you a set of tools, but not overfeed you, and let you have some time with us to see how we troubleshoot.
And part of that free swim time, and as well as we're all at different levels of experience. And I want you to feel like you don't have to sit on your hands and wait as we go through this. If you feel up to it, I give you a bunch of project materials. So if it's something that you feel like you start grokking pretty quickly, feel free to grab one of these projects. Also during free swim time, there's 11 different things in here that take you from like drawing a basic line to getting into some 3D visualization stuff. So video processing, etc. So these are some projects that if you feel, I want this to be a learning time for you and a time that you can ask questions. So if you feel like you're at point C where everybody else is at point A, feel free to move ahead with those sheets, and then we can answer questions as you move forward. So processing is a text-based language. So a lot of the different languages, some of them are drag and drop block programming. It's a text-based computational graphics. So we're looking at something visual. Arduino language is usually to get hardware to do something, turn on lights, turn on motors. This is visual. It's designed to be on the screen. Originally was created to get artists making cool art on the computer screen. So starting to look at the computer screen and computers in general, the web, as a canvas for artists. At the time of its creation, it was pretty, I wouldn't say hard, but time-consuming to learn a computer language that can produce the graphics. I wouldn't say quality, but the intricate graphics that you can with processing. It's human-friendly in terms of readability. So you've probably ran into this with Python and some other languages. A normal person, when you look at it, you're like, I have no idea, right? That's kind of crazy talk. Processing, when you look at it, you can somewhat decipher it without even knowing what it is. Again, like I said, you can produce 2D graphics as well as get into some 3D stuff. What processing is, and I wish I had the actual image for this, but I'm stealing a t-shirt. It's people doing strange things with software. I mean, it boils it down to that. Doing really weird things with your computers. Here's some examples. So this is when we talk about the hardware interactivity with software. Yeah?
Maybe a slide. Were there numeral 5s in that URL?
Yes. So it's it actually redirects you right to processing.org. So no, it's okay. So here are some different, this is actually some hardware applications. This is still a software application, but this is called Petting Zoo. So it's a dark room with all these kind of intricate, odd light up shapes that, as you brush up against them, produces different sounds, things like that. Producing intricate, elaborate 3D shapes and then exporting that to a 3D printer. This is a DJ turntable that doesn't use any records. It just uses, I think, an infrared beam that tracks whether there's these strips on the turntables. This is probably one of my favorites. It's a rug that's designed off of binary code and glitches in the computer. And then probably the one more ephemeral is wall of plastic bags, grocery sacks. We've all seen them. And then as I move closer to it, the bags inflate and deflate as I interact with it. And the last one down there that looks like a bunch of roads, it actually is roads. It's traffic patterns, creating music with traffic patterns. So each one of these dots is a car driving in the street. And when they cross another line, they make a musical note. So you get this odd sense of sound. And this is probably what a lot of people use processing for. It's what we use processing for here. This is kind of data visualization, graphing and dashboard applications. So this is kind of showing different collaboration networks across Europe for, I think it's a medical institution. Not quite sure. I was just looking at it in terms of, but it's interactive, so it's on a touch screen, so I can move it around and open up different institutions. This one, I ran across this one this week. So this is the movie Road to Perdition. Frame by frame, put into one image. So you run the video through processing. Processing takes each individual frame and then puts it into one image to show kind of the graphic pattern that movies take. So Road to Perdition's a pretty dark movie, so you can see this kind of black and white stripes. Something like Willy Wonka would be much more colorful and insane. And then I give up. It goes beyond I could spend 8 hours showing you projects from processing. This is a application written in processing to design computer-generated dresses. So basically, you see on the screen outline of a woman, and you just essentially just click around, and it generates this dress from these points that you give it, and it creates some of these dresses. Some of them, I don't know if you would want to wear them or not, but it generates them, and it's the fun part of it, right? It's design. So we use processing because it's open source, and it updates on a regular basis, and it has a big community behind it, similar to the Arduino community, where if I run into issues, I probably 100 or 1,000 other people have run into the same issue. It's expandable, so once you kind of learn the basics, you can start plugging all of these other libraries. You can talk to Arduino with it. You can start looking at computer vision. You can even write Android applications for your phone in it. So there's a lot of these other things. We call it the glue that sticks all of our stuff to the computer and other things. So it's sockets, and so you start getting kind of this ecosystem with processing of different applications, being able to connect different things to it. I just got set up, so we're going to actually show you a really quick computer vision example, as well as a couple other hardware examples. I think since we have some people that have some experience with Arduino and microcontrollers and things like that, we'll have some examples this afternoon. And then I have an Android app, really simple one on my phone, that I guess I could pass my phone around. You can play with it.
We're in the process right now of porting a microcontroller called the Yo-Yo, which we make with Google as a kind of a direct descendant of the Android device. But the Yo-Yo socket's now to processing, and we're about ready to spin a whole kit that's Android development in processing. So it's huge what gets done. I think Derek and I had this discussion before that for certain tooling, there are probably things that do things better than processing in specific instances, but not more easily. Like, we use it because it's a quick tool. It's like the Swiss Army knife with the glue, like I said. We use it to glue a lot of things together, to work on a lot of different stuff without having to get highly specialized tools. And it really does excel. I'm a little barrier for entry.
Yeah. Yeah, go ahead.
So at its core, is it like Arduino in C?
Arduino is processing. Arduino is a version of processing. So processing, is this in your slides?
Go ahead.
Processing was done in the early 2000s at MIT at the Media Lab. And then in the mid-2000s, a graduate student named Ronaldo Barragan took processing and ported it to a version for controlling microcontrollers called wiring. Wiring was kind of appropriated into the Arduino language and exists as Arduino today. And as we move through the basics of processing today, you'll note the remarkable similarities between processing and Arduino.
So all of these, if you drive down to the core, are C++, right? Or essentially, you
C++
can-
and Java had a baby, it would be processing or Arduino.
Okay. But I can import my C code, I use C code just like I do with Arduino.
Yes and no. In Arduino, the compiler, Mike, do you know if it should, in Arduino, it definitely will because it's riding on the GCC compiler.
Yeah, absolutely.
But in processing, I can't make you that promise. I've never tried. I just go, if that's the case, then usually a lot of the time I'm just in C++.
And these are a lot of the different applications. Put Xively up there. It's a kind of a data warehouse, so I can push information from processing and Arduino up onto Xively. It's not quite what it used to be. We're kind of like, we kind of promote it because it's the best thing out there right now, but it's not the best thing, if that makes sense.
Xively is the outgrowth of a chain of tools that started as Patchday, and then it was Casa, and is now Xively. And as it has been sold, it has changed in its kind of open source stance somewhat, and the documentation has gotten a little bit less community based for us. We still use it, but both Derek and I are interested and involved in trying to figure out how to apply Internet of Things to the world. So we use Xively because it's the best tool out there, but by no means is it the only tool. Again, it's a low barrier for entry, but there are other tools. And then I'm not trying to be disparaging about Xively at all.
No.
Just don't get me wrong.
That's fine.
So what do you use it for? What
Do you have? I'll put my Xively feed up later.
I don't have it.
So if I want to push data to the internet, if I want to make my data available, so Xively is like data TV. It's probably 250 to 500,000 channels of data from sensor networks all over the world.
That's good enough.
So again, Jeff talked about who developed it. And if you kind of track student to professor to student to back all the way, John, I always pronounce his last name wrong, Maeda. You can actually watch the TED Talk. I actually really recommend watching his TED Talks. And he was kind of, the one that I have here is him talking about how we can use the computer as an art medium. And kind of some of his early works, which very oddly look really similar to processing. So really recommend that. So how do I get it? I know a lot of you have been sitting here. You might have started to download it already. If you just go to processing.org, and you can skip one step and go /download. I recommend 2.03 So if I go to processing, option for download here, and I'm not going to donate, sorry. If you're a Windows person, again, we recommend the 32-bit system because it allows you to, it'll allow you later on to communicate via serial to hardware. 64-bit is still wonky in terms of being able to communicate with an Arduino or anything else that communicates over serial. So 2.03, which is right here, is what I would recommend. It is also what works best with Android mode as well. So if you're looking at, in the future, going into Android mode, Android development, 2.03. So I'll let you go ahead.
I'm going to add what Derek's saying about 2.03. I ran 2.1 in the class about a week ago and crashed. So it was a really long day.
So we kind of live and work on this in this world of everything's beta, so everything's kind of in flux, and so we're somewhat used to like something not working and just downgrading and seeing if how it works or writing some code to work around it. But through that, we kind of figure out what's most stable for you and what would work for you the best. And so that's why I recommend 2.03. So I want to make sure that everybody's got it installed before we go any further. Ah.
You know what? If you install the most recent one, run it.
That's fine, because for
If there's some problems, we may have you back up later on. But for what we're going to do to start off with, it should be fine.
Yeah.
My suspicion is that if we see errors, it's going to be around the serial port, and it won't be till 7.
Yeah.
Maybe you can chase that down.
everybody good? Okay. Still downloading.
So we'll roll out some of our projects as the day progresses. I think I use processing for one thing or another every day of my life. So I have this, it's really interesting, I have a relationship to this software, which I never thought I would have.
The one thing that I find with processing, it allows me to start saying to myself, we use software all the time. So like when I have a phone app, I'm like, I can make this better. Like it empowers me to then just make things better. And I've been doing that for a while with hardware, with Arduino, but now with processing, it's like, walk around and you find expensive software and you're like, I could probably do that in processing and it'd be free.
The other thing I see, like just off that, is I'll wander through the world and I see processing in places all the time. Like I go, hey, that's processing, or that's gotta be processing. So.
Oceaneering.
Oceaneering. Yeah.
So basically the download for processing, you just unzip the file and then the executable is already in the folder there. So you don't have to find some install executable or anything like that. It's just right there. Really nice thing, you can put it on a USB drive and then just run it off of that. So if you're going to school and you want to have processing with you all the time, plug it in, run processing, and it'll run. You can even drag it over to your user account. You don't have to install it. And it's a good way to get around IT, having to vet your software for teachers.
One of the
Sorry.
nice things about processing, well, just this is specific to processing in the classroom setting, and we're acutely aware of people here who are working in the educational setting. Arduino is difficult because it requires the installation of drivers, which a lot of the time requires an IT administrator's privileges on the machine. Processing does not require that. Are you the IT person? Yeah.
I have privileges. I love that segment. I have privileges. So a couple things you have in front of you, like we talked about before, the graph paper notebook. I still use graph paper all the time because processing it uses the Cartesian system, and instead of having to guess constantly where things are going and fudging it left and right, I'll actually just whip out some graph paper, draw a scale version of it, and make it so we got you a graph paper notebook to be able to work with that. things like triangles, like it's easy to do rectangles and ellipses, kind of guessing, but when we get into skewed quads and triangles, you really want to be able to know what those points are and not have to guess. Hot sheets I talked about in the folder, that's what they're called. And they're great materials, not just for a teacher, but you get home and 3 days later you kind of, how did that work? How did I hook this up to a makey-makey? That's some easy materials to go through and play around with. So what does it look like? Right now I'm going to jump off of a presentation and we're going to get into processing. So if you have it, open it up please, and we'll make sure everybody gets up and running. So open up processing. Perfect. Can everybody read that, or do I need to make my font bigger? Pretty good?
So Derek's going to make his font bigger. He goes to the file selector and he goes to preferences. When he opens preferences at the top of the sketchbook location, it shows me where it stores the programs that I've written. Processing creates a folder within your documents called processing, and then stores everything that you save to that folder. The advantage of this is as you upload new versions of processing or different versions of processing, all your pre-written, all the code that you wrote before that is stored to your documents. So it's not dependent on the version of processing that you have. He's going to change the editor size here. There's a bunch of stuff, selections along these things that are fairly self-explanatory. One of the ones that I always uncheck is check for updates on startup, because you get this little script window that says there's a new version of processing available. Would you like to download it? And I'll tell you when I want to download it. I don't need you to ask.
And then one thing I always check is at the bottom to automatically associate PDE files with processing. So then I don't have to go open processing and then go find the file that I want to run. So my font's bigger, and I'm actually going to relaunch processing because it's one of those things about, again, the beta world that it produces kind of a bug. So we kind of change preferences, close processing, and reopen it.
There's a cursor thing that happens. If you have this, if you do this, and you're like, wow, my cursor's all funny. Close the application and start it again.
So the basics of the processing window. So we have kind of a normal text editing window, just like any, you could write a paper for school in this if you wanted to. I wouldn't recommend it. You have a play button and a stop button. So if I want to run my code, I hit play. If I want to stop my code, it's producing a whole lot of errors. I'm going to hit the stop button. And these are the visual buttons for new, open, save, and export. So we can actually export this as a Java application. We can export it as an executable. So for Windows users, you can actually have us create a standalone software package so that they don't have to have processing to run the application. Under File, you have all the wonderful things like this. One of them, so your sketchbook goes back to that processing folder. So it'll pull up all of the processing sketches that you've created and saved in that folder. Recent examples. The example suite in processing is enormous. And for every library that you download, so for every piece of software that plugs into this, they also have example software. So these open up and expand. And so if you wanted to do something with lights or an image and you forgot how, these actually are really, really, really good examples of code. A lot of times I'll even take the example code and just modify it without having to rewrite from scratch.
So this is much the same as the examples that come through people who are familiar with Arduino. These are web-based. They don't download with the environment, so this actually calls from a web file.
It's with the environment.
Is it with the environment?
Yep. It's okay.
It's impossible, I think, for most normal human beings to remember all the code. So these are like the dictionary for me. And a lot of the time, Because software development has so many layers of complexity, I'll take examples like this and basically collage them together to get a program. So I'll go in and grab somebody's functionality, I'll alter it to my needs or wants, and then glue it to something else, and this is a lot of the building process.
Perfect.
Do you want me to?
No, you can drive.
All right.
I'll talk. So, Jeff's going to close the examples here and delete my hello. A processing sketch, just like an Arduino sketch. So the program we create, so the code we write is called a sketch. So that's what I'm going to reference. Essentially, the basic ones have two parts. There's a void setup, which runs once, right? When I launch the thing, it runs once. And then there's a void draw. And void draw runs at 30 times per second, which is the frame rate of processing. And we can change the frame rate, but right now, just think of it at 30 times per second.
So when I write code, this is how I start. And if you've done work with Arduino, a lot of the time you'll notice if you open bare minimum in Arduino, it's got void setup and void loop. I take that same framework, push it to thinking about processing, and I start all my sketches exactly like this.
Perfect. One of the ways I explain the difference between void setup and void draw is void setup. If you think about a recipe, void setup is all of those things that I need to get out, all the ingredients in the recipe, and then void loop, or void draw, excuse me, is the step-by-step instructions that the computer's going to take. So the first thing we want to do is we want to create a window for our program to reside in and function in. So we're going to type size. And notice that Jeff put open close parentheses and then semicolon. So this is called syntax. We all use syntax, even those people who this is the first time seeing code, because at the beginning of every sentence we put a capital letter. At the end of every sentence we put those of us that write pretty well, put a period at the end of a sentence. And a question mark goes at the end of a question. Same thing for computer language. Processing, every function has an open close parentheses, and then we end it with a semicolon. And what that semicolon is telling the computer is that piece of instruction is done and go to the next instruction. We're going to put two numbers in size. So Jeff's going to put 1200, 900. What this is going to be the size of the window in pixels. So the first number is its width in pixels. Second number is the height in pixels. Hit play. Yeah, whatever. Congratulations, you've all written the first program for processing. You've made a window. Not very fancy, but you've made a window. Okay, so we can close that window. So one of the things is people like to minimize things. When you're opening and closing processing sketches, make sure that we're closing them, because you can easily, forget it's there and you hit it and it just turns into a mess. So make sure you close it or hit stop. So we have a window. Next thing we're going to do is we're going to create and change the background color of that window. And we're actually going to do it in setup. So we're going to type background, and I'm in people's way, so I'm going to move out of the way. Again, syntax, open close parentheses, semicolon. And we're going to pass it 3 numbers. Now, those 3 numbers are a red value, a green value, and a blue value. The maximum number that we can have of those 3 is 255. So Jeff, give me a red background. Yeah, there you go. So we're going to give a red background. And Jeff right now is creating what's called a comment. So if I go // anywhere in my sketch, anything after that on that line, the computer won't see. So it's for human eyes only, which is really nice because when you're working on something and you come back to it a week later, right, we want to be able to remember what I was working on. Or if you're like me and you send Jeff code at 3 o'clock in the morning, you want Jeff to be able to understand it when he wakes up at 4 o'clock in the morning. So we leave comments.
I don't leave comments.
No, he doesn't.
I don't. I just, it's a trail of breadcrumbs you gotta follow, but I'm bad about it.
So here's a red background.
SparkFun red.
Because we put 255, so the maximum red value, and then 0, 0. Now, we can kind of guess. The more you spend time with a red, green, blue value, you kind of can get pretty close. But if you want a specific color, like SparkFun red has a given like hex value color, red. And I don't even know what that is, so I can't tell Jeff what it is. But we can say, we can go up here to tools, and there's a tool for us to use as color selector. So if you've done any web design or graphic design, you're probably used to a hex value, but you also have red, green, blue values. And so we can move around. So if we want Jeff pick a color, please don't do fuchsia pink. Tealish. We can select this hex color if we wanted to, or it also gives us our red, green, and blue values that we can put in there with a comma separation. So Jeff put in the hex value, gives that exact blue.
What's really interesting is that you're not seeing it because of our projector, but these are pretty close to Pantone values along with. They're very good.
We normally like to use the comma separated values because that allows us to use we can create variables for those numbers and change those numbers. So if we want something to change color, we usually use the RGB setting. So Jeff, if you can go in and grab the RGB value of that same color, that'd be great. You know, if you wanted something to stay that color the whole time, you could use a hex, or depending on what your application is, but we like to use the RGB value. 10, you want me to write it down?
No, I got it. I'm just, can I play with this really quick?
Go for it.
So,
Go for it.
we can go rectangle next?
Yeah.
Okay. I'm gonna jump Derek's ship a little bit here.
We do this to each other all the
Because I want
time.
to talk about the difference between using, if I use a standard red, green, blue value, it's going to be a close approximation of the actual color that I have. But I'm not going to get the hue, saturation, and what's B again? Opacity?
Ask the graphic designer. Right.
Brightness. So I'm not going to get those three values. So I'm going to get a close approximation of that color, but not the exact color. So what I'm going to do is I want to look at the difference between red, green, blue, and the actual color, but I'm going to do this by exploring a shape. So I'm going to go down to draw, and draw runs over and over again. Derek talked about this, running 30 times a second. I'm going to give this a recognized command called rect, which stands for rectangle. I'm going to pass this 4 parameters, 100, 100, 100, and 100, all comma separated. My first two values are an x coordinate and a y coordinate, and we generate from the upper left hand rather than the lower left hand corner. So I'm saying create a rectangle 100 pixels out from the left hand side of the screen, 100 pixels down, please make it 100 pixels wide and 100 pixels high. So when I run this, here's my rectangle. Now I'm going to go back to my sketch. So good? So far so good? I'm going to go back to my sketch and I'm going to add a command above this called fill. In that command, I'm actually going to put the red, green, blue values. And we're going to look at these next to each other and see if we can tell the difference. So from my color selector, I should still have the original selected, and this is 10, 178, 242. indistinguishable. Is it always like that?
I don't know. But it's a good exercise.
I can change these numbers, of course. Do it. Do it.
Do it, do it.
Make the last one 0.
All right, I'll make the last one 0. I like audience participation.
And you can as well change whatever color you would like.
Oh, look at that. There's another corresponding palette going here. How are we doing so far?
Great. But a lot of people are probably asking, like, why are you showing us this when you can, like, do this on Microsoft Paint? So, which I get, actually, kids will, you know, they'll be like, why are we doing this when I can use, like, Photoshop or GIMP or Microsoft Paint? And right now, we're going to show you the difference between the two. The very simple difference between the two. So there's we always have a cursor since 1981 or 83. Whenever the mouse was invented, there's a mouse cursor. And that has an X and Y value on the screen. We can use those as a variable. So instead of having a static number like these, we can actually pass it a variable that we can control and we can change. And so we're actually going to put in for our X and Y value for our rectangle, mouse X, and this X is capitalized, and mouse Y. So the X and Y coordinate of our mouse.
Notice these change color. These are recognized parameters that we can pass to these commands. And there are a lot of them. But you'll recognize it's kind of a beacon for correct spelling, syntax, capitalization when we're passing these parameters that they change color. So if I'm looking at the predefined parameters within processing, I know that I nailed it when it changes color.
I call them system variables too. So, you know, things that are, it's a built-in variable that, you know, reads a mouse X with a mouse Y or previous mouse X, Y, etc. Hit play, and then move your mouse around. Whee! So we get a crazy rectangle. So the next shape that we can play with, actually, and it's going to be a really quick change, is so we can change rect to ellipse. E-L-L-I-P-S-E. And if we hit play, it's now a completely different shape. It's a circle. And we get this kind of funky worm-looking thing as we draw it around. And the slower I move, the closer these circles are going to be together, because it's based on our frame rate. So that's the distance. So this distance between the center of this circle and the center of this circle is the distance that my mouse traveled within one frame, or a 30th of a second. Cool. So now, what if I just want that circle to like move around and not leave this kind of tracer crazy thing behind me? This background, right? Remember that this runs once. So I'm running, think of it in terms of collage, right? We do put your like best kindergarten, first grade hat on, like you cutting out all these shapes out of magazines and you're gluing them on a piece of paper. Well, we have our colored piece of paper, and then we're gluing things on top. Draw is constantly gluing over and over again. If we put background inside draw, that means we're going to get out a new piece of paper every single frame. So if we hit play with the background in void draw, now that circle follows my mouse without leaving any type of trace element. Does it make sense to everybody? And if you have questions, interrupt me as much as possible. You want to do some bouncy bounce?
Let's do some bouncing.
Cool.
Yeah.
Go for it.
So this may not be the time to cover it.
Uh-huh.
Why did he get this?
Ah.
Let's do that. Let's do that. So Arduino and processing come with these wonderfully well-documented environments that not only highlight my error, but down at the bottom of the screen, if you can see it, it says the function of this does not exist. It says, I'm looking for 4 things. I'm looking for something called ellipse, but I don't find anything in my predefined functions, and I don't find a variable named that. So this is not recognized anywhere in the program.
So we're going to add the L back, and then Jeff, I want you to do the find and reference. So let's say you're at home and you forget like how many numbers am I supposed to give it an ellipse, and what are the numbers? Jeff's going to highlight the actual function name, not the whole function, but just the name of the function. Right click, and he's going to go to find and reference, and it brings up the HTML page for processing. Even if you're offline, the whole reference segment of the processing website comes with processing. So it'll automatically pull it up whether you're online or not. So it has an image of what an example is, an example function, has a description of it, and the parameters that I need to pass that ellipse. One of the things that I always look at are the related functions to it as well. So if I wanted to change a couple different things or look at functions that I could use with an ellipse, it's right there. So I can change the ellipse mode, for example, which allows me to set the origin, so that X and Y coordinate origin, to center, corner, or radius.
So there's a whole dictionary that downloads with processing,
Yep.
which is just amazing. Oops.
Actually, I don't think it downloads. I think you have to go to the web to get it right.
No, so that whole section of their site actually downloads with processing. So it resides in it.
So the other way to do this is to go to help. You can do find and reference from help. You can also do reference. And reference opens up all of the major recognized commands in processing. So if I wanted to know what colors I can paint on this palette with, here it is.
And there's a lot of them. I'm still playing with, I've been using it for 3 years, and I'm still playing with what can I use to do what with. I think every morning Jeff shows up and I go, look what I did, Jeff! Look what I did!
Or vice versa.
Yeah. And you know, if you're looking at where am I supposed to put a semicolon, I mean, it even has a reference to just the semicolon. So where's the semicolon supposed to go? You know, what do curly brackets mean? So a lot of those, especially for beginning classes and reference stuff, it is essentially a textbook, a useful textbook. Cool.
I'm going to actually, I'm going to change some stuff here. I'm going to give my 100 my mouse position. Now I'm going to go over here and I'm going to start to control the shape.
That's okay.
I'm also going to take background and I'm going to move it back into setup because visually this is really satisfying. So now I have this pretty psychedelic interactivity going on in one corner. I want to move this into the middle of the screen. So I have a height of 900. I'm going to divide that in half and change this number to 450. The next thing I'm going to do, Derek, where were you headed?
You want to move it over? So 600. Change this to 600, the X.
Okay.
And so mouse X and mouse Y, we can put it, where Jeff's getting is that we can put it anywhere, any of these numbers. So he's got this green, crazy shape, the Eye of Sauron. But let's say we want it to change color depending on where the mouse is. So we can use mouse X and mouse Y in our fill color. In fact, do mouse X and then mouse Y, and for the third number, do P mouse X. P mouse X is the same thing as mouse X, it's just the previous mouse X.
Capital P?
Nope, lowercase.
Capital M?
Nope. Or P mouse Y, either way. So it was the position at the previous frame. So it'll be a little delayed than where the mouse actually is. So now we have this kind of wonky, and
As we get outside of 255 in the range, we go to all the way white.
cool. So again, let's put our math hats on here. Jeff always laughs at me because like the teacher part comes out of me. So if I want to be able to change a number, I use a variable. Well, we can create our own variables in this environment. So at the very top, right above void setup, we can create a variable. And the first thing we have to do is give it a data type. And so data types, think of data types as different types of buckets, or I like to use like the plate versus bowl scenario. If I'm going to eat chicken soup, I don't eat chicken soup out of a plate. It's just not going to hold, it'll hold like 2 noodles and everything else is going to be on the floor. So we have different data types that hold specific types of numbers and or characters or different things. So I can eat chicken soup out of a mug, but I can't eat a steak really out of a mug very well. So we're going to create an integer, or int. And we're going to be really creative in our naming. I'm going to call it x. And I'm going to make it equal to 600 for now. You can create your variable name whatever you want. If you want to name your variables after your pets, feel free to. The reason I named it x is because I'm going to actually exchange this 600 in the ellipse for x. Two main reasons why we use variables in code. One, that it's going to change over time somehow, so that we can change it. The other one is if we use a number over and over and over again a lot, we tend to use a variable so that we can, if we want to change it, we can change it once instead of going through the code. If I have 100 lines of code and I have the number 13 everywhere, I can just use a variable and change it at the very top rather than have to go through and edit that. So if Jeff hits play, this should be the same, right? Theoretically. Which it is. Good. Computer obeyed our orders. If I want that x to change, let's say if I want x to get bigger, what do? I can say, if I had my algebra hat on, math hat again, I'm sorry, I can say x equals x plus 1, semicolon. And Jeff's going to hit play, and now it moves at 1 pixel per frame. which this is like the coolest version of bounce it's ever going to be. And it's going to keep moving, and computers are dumb, so it's going to keep moving all this way until I tell it to do something else.
Because it's headed for Firestone right now.
And what I want it to do is when it hits that edge of the screen, I want it to bounce and come back the other direction. I want this thing to stay on my screen. So what we're going to do is we're going to actually create another variable. We're going to create another int, and we're going to call it grow. And we're going to make it equal to 1. And then we'll go down here and we'll actually exchange this 1 for grow. Jeff's a copy and paste guy.
There's a reason for that.
I know.
You got to copy the whole thing now.
And it should function the same way. So hit play. We'll double check. And I do this all the time. I probably hit play once a minute when I'm coding. So if I want this to move faster, what are we going to change? Frame rate? We can change grow. So we can make grow equal to 5. But it also goes off the screen faster. So we're going to use an if statement. So we've all played Simon Says. An if statement is a computational Simon Says. And I actually have a pretty good frame on this. So we'll go back to the presentation really quick, Jeff. I'm sorry.
No, that's fine.
It's on Google. Nope. And pizza will not be here at 1. Probably like 100 slides. So forward.
So,
what?
I just, as long as we're threading through, you don't have to use ellipse. You can use any of these things in terms of the geometry. I'm using ellipse because I feel like this visual that we're creating is one of the more satisfying ones that are created easily. So,
Talk about reference. We'll get to fill and stuff. Oh, we already did fill. Talked about mouse X and mouse Y. Keep going. There we go. So an if statement looks like this if we were to map this out. So when we're playing Simon Says, right, you only do something when the person says Simon Says. So we have, that's the condition of Simon Says. And if that condition is correct, so they say Simon Says, you do what's inside the conditional code. So you take this little jog. If that person doesn't say Simon Says, or if that condition is not met or false, we skip over this conditional code. So it's a big if statement. It allows us to put decision making in our code. So we can go back to our code now that we're up to date with our slides here. And Jeff's going to type out the syntax for if. So if has its own parentheses, and then he's going to drop down a line, and it also has its own curly brackets. Since it has basically it's a branch of code, it acts like its own kind of paragraph of code. And each paragraph of code kind of has its own curly brackets. So we're going to put a mathematical statement in here, in the if statement. So we're going to say if x is greater than or equal to width. The reason I put width in there instead of the actual width of your window is so that now I can go back and change the width of my window. But also, if you're like me and you're in a class and you're looking at something and you're a visual learner, you'll type whatever number is in there, even though your width may be different. So width And we're going to go down here. We're going to inside our curly brackets. And we're going to say, if that happens, we're going to do grow equals. We want grow to go negative. So we're going to say grow equals grow times -1. And a semicolon after that.
So why the semicolon here?
Why the semicolon here?
Why the semicolon here? So if I look at this if statement is a command that remains open until it's satisfied, and it only closes when it hits that conditional. So it checks that, and then once it executes the -1, it closes it and starts all over again.
So Jeff's going to hit play, and we're going to see what happens to our ellipse. So our ellipse is going to move slowly to one side of the screen, and that x coordinate is going to hit the side of the screen. It will go back the other direction because we multiplied grow by -1. So a positive number times a negative number is a negative number. And it's going to come back the other direction. And bye-bye.
Or.
Yep. So we're going to close the sketch again. And we can actually, so we have a simple argument in there, right? Our condition is very simple. It's one condition. We can actually put multiple conditions in here, conditional statements. And Jeff's going to use an OR sign, which is double pipes, which is shift, and then the key above your enter key.
Shift backslash on
Yeah,
this keyboard.
shift backslash. So this is going to be x is greater than or equal to width, or x is less than or equal to 0. So it's either this maximum or this minimum. And if we have a negative number and we multiply it by a negative, we're going to get a positive. So it'll go back in the positive direction. Changes direction, comes back, and you're a bunch of weird people doing weird things with software.
So what if you were in the middle of the screen and you wanted to stop?
Good question. So we're going to code on the fly. So Jeff's going to close this.
Key pressed.
So we're actually going to put, because we're going to make it equal something. So there's a question. So here's a good thing to get on this. So a single equal sign is a statement. All right? I can say x equals 3, and it's going to tell, I'm telling it x equals 3. Two of them is a test. So it's asking the question, does x equal 3? Or if x equals 3. So if we start, so Jeff, give the x value instead of 600,
Okay.
give it 0. Or 1. Let's do 1. So don't mess around with it too much. And we're going to change our if statement. So we're going to say if x double equal sign 600. And instead of multiplying grow by -1, we're just going to say x equals 600. Or grow equals 0. So it's going to go to the center of the screen. Bummer. X equals grow. What's grow? Oh, because grow equals 3. It skipped over 600. So make grow equal 1 at the top. No, at the. So if you notice, I did the coding dangerous thing of like, basically if it equals an exact number, well, if I increased by 3, it jumped over 600.
So in your conditional, you could have said greater than.
Yes, I could. Yeah, I could have.
That's why, yeah, that's a lot of the time why you use greater than or equal to. It
Should do this. There we go. So it stayed there. Cool. Donuts.
Break really quick.
Yeah.
People want coffee, donuts, a quick break.
5 minutes, 10 minutes.
5 minutes. Bagels, help yourself. There's a toaster in the break room. You can pay leftovers.
Way too many carbs. No, it worked out great. No, it's also if. It's just if. Because it closes. So if, but then when you close curly, you come back to whatever you're working on. So it has if and then something else inside of here. Yeah. No, that makes sense because, but it works. It's different for visually. Because if you did this with color, so if you did a mouse, if mouse X is greater than like half of width, it does that. So if you make, but if you're dealing with the math here, yeah, I like it a little way. No, it's always been a rectangle. I have, and then I put the fill color so it changes color. But,
Right.
yeah, and it intensifies the people doing weird things.
Right.
It's coffee.
It'll be there if you close it. You're welcome. You're welcome to, if you want to. We can save them for cracker. Right. We can save them for cracker.
Excuse me.
Click and drag processing down here to the barn.
Yeah.
When I was here for the Arduino. All you have to do is email education.
Tell you what, I'll get you my card.
I actually went to school.
Let me get you my card, and then you can email me directly. So so if you're looking for curriculum, I just created this week. You do curriculum at SparkFun.com. It comes directly to me, but that's an inbox that I have for directly answering curriculum questions. But I'll get you my card anyway, so they can email me too. Thanks.
So tomorrow there's robotics, big game development. On Monday, there's a computer class, a casting class, which unfortunately is full.
How do you find a voice cast down?
Tuesday is our meeting at 7 p.m. After that, there's a couple of classes, one about robotics, one about computer networks. So we get together and teach each other things. We actually have a space in the
Yes and no.
right next
So
to
one semester class or your
Yes, some of them.
the other thing we do is we all pitch in a little bit and buy expensive tools. So we have three 3D printers of varying sizes. We have a laser cutter. We have a kiln.
So on these rockets, a lot of guys
They're
watch.
building a small CNC. We're actually in the process of ordering a CNC that was a 4x8 sheet plywood, or actually just metal. One of the guys is bringing a tile cutter tool that we're
I make sure I get a lot
that
before it gets
I know
to
you
the
Python right now,
So
and that's not a
we get together and buy these tools, and
So I
it's
have
one of
freshmen
those
in
I
there.
can drop
We're doing head
$2 grand on the
levels.
CNC myself.
I have a senior
And I
who's
don't
on
have to run my
robotics.
garage to keep it.
Like that, everything.
I can pitch $200 on what this helps me make space.
Well, that's the weird thing, so they're very high.
It will generate content, so I will live all
Right, okay.
as well as a usually the accelerometer to make sure you like how to model.
It's a great printer, so
I'll pull up our rubber balloon package, our rubber
So in
balloon.
terms of like, I only draw rectangles,
Right.
right? Well, I just have a rectangle function and then
Sketches.
Yeah, that's what I'm adding my copy.
So you don't wanna have to learn this install play game and then set everything up.
Into development, I built a trust.
I think this, that's what I'm hoping next year, that processing. Will be a one semester, like, will semesters worth.
So these, I built a semester class. But you can easily, it's just an elaboration on material.
It's really neat, like, I was-
Well, and I'm also doing kids who don't have probably the
a couple
basics.
photos that built
So the,
more interactive. So
the first project one, pixel art, it's not a week, for high school, it's not a weekend project. If they start with new graph paper, they have to draw that,
like this.
and then they have to transfer that to.
Yeah,
As
long as you can get data. We'll do that.
Very good exercise.
So it's like back up, so you get to the right spot, and then you can.
So it's like hammers it into their head before you can touch them.
Yeah. This is cool.
That is good.
It's going great.
I'm
The trouble too.
already so excited that.
I was pressing on
Yeah.
continuing lines and all that crap. And so it laid out really nice. And it was good to see that preserved words, not just mouth at the time. What happens if I pick one of those?
Sorry?
What happens if I pick,
Get mad at you.
so just give me a syntax error? Right when it was showing my run.
And then it's like, so there's a different types of, so now talk to everybody else that uses mode. So in the upper right hand corner, you probably saw the drop down box versus Java, which is Android
Yeah.
mode. So that's where you can change, like, when I'm writing an Android, I change that to Android. So there's a bunch of different modes that instead of, there's, I think it's called live mode or whatever, that allows them to change those numbers when it gets the sketch running. So like if they're looking for something, they have a red, but they want to but they don't want to keep going back and forth, they stop and
Close
play.
it, yeah.
You can actually change that number and change it live.
Really?
There's all these different types of tools, and one of those is like, well, if I change this variable to something else.
You guys are doing great.
Life quality
of everything.
We're really
There's a debug mode.
But that's how to.
Yeah.
I like that.
Cool.
And I like the symbol, the code, I made mistakes. Okay, we just changed a couple of things. What, oh, it's that. That's just a great way.
Yeah.
How would you
And I know you're waiting for later on, but if you have questions, feel free to ask them.
Yeah, exactly. Yeah.
So our work is joining. About 90% of what we do is joining.
That's the way to figure the most out.
You hold the wire, you're soldering your teeth while you're soldering.
Do you need to have like a lot of soldering experience before that educator class?
Nope.
They do this in person, that's an assignment.
Yep. So that's to teach you how to solder.
Oh, okay.
Yeah. We're actually going to be there at noon tomorrow. Having a meeting about our website, creating our website from noon
So we're going to pick back up again. I wanted to start out with, we talked about data type variables used in integer. Quick slide on the couple different data types. There are probably 10 different data types because each one of these has like a long version versus a short version, etc. So an integer, just think of it as a whole number. And usually it gives you a range between like, I don't know how many numbers, and negative, I don't know how many numbers. But just think of an integer as a whole number because you're probably 99.9% sure that you're not going to run into the borders of an integer. Float is a decimal number, so any number with a decimal point. A byte is, interestingly enough, is a whole number, which is 127 to negative 128. It's odd.
It's positive or negative 2 to the 7th because
Yep.
it's 8 bits. So 1 bit is a positive or a negative identifier, and then you have 7 bits that write that number.
A character or char is a letter, typographical variable, and Boolean is true or false. If you're thinking of a word, that is a string, or a series of characters is a string, and that's in quotation marks. Character is within single tick marks. Cool. So let's move forward here. Talk about variables. Step forward. So the one thing with if, be very, very comfortable with if statements. It's kind of the, I would say it's the initial stumbling block of people starting to learn code. A lot of people will, if you're doing an if statement, they'll put a semicolon after the argument, and that'll kick an error. And it's not an error that will highlight very easily. So, a lot of times so if we put put a semicolon after the if statement, if I hit play, it skips over the if statement, but it's not working very well, right? So it actually doesn't facilitate the if. So, and it doesn't kick an error. So you're kind of scratching your head going, what is this thing? Where's my problem? Why isn't it working?
It turns that line into an instruction.
Yep.
So it says if x is equivalent to 600, and it never goes past.
It goes down here. So that's one of the biggest things that people run into with an if statement. Sometimes you get stuck in an if statement, depending on what you're doing and how you're using it. If this thing is kind of a Boolean that always is true or false, and you change that in here, so like let's say if x equal or double equals is true, or if this is false, and you make it true, and then you don't make it false again anywhere else, it's just going to stay true. It will skip over this if statement over and over again.
I'm going to go to reference really quick. And if is
Control F. if.
There we go. So conditionals will give you all of these places where you can use program flow stuff. And the suitcase is another one. Spending time with this and learning how programs flow is a pretty profitable endeavor in my estimation.
Go back to the slides. We should have got a second projector.
Yeah.
My bad. Move on. So we gave you your word warning. So the next thing we're going to, so I lied a little bit at the beginning when I said like you have void setup and void draw and that's it. Well, in the beginning, it's like training wheels, right? So we're taking some training wheels off for you. And we're actually going to get into some what are called event functions. Event functions are functions that only happen when that event happens. So as you can see here, like one's called key pressed. Well, whatever code I put inside of void key pressed is only going to happen when somebody presses a key on the keyboard. We're actually going to play around with mouse drag right now. Just to play around with it really quickly. So we're actually going to open up. So save, what I would do is save the sketch you have now. And we're going to open up a new sketch.
So in order to save, I'm going to grab File, Save As, and it will give me the option to title this. Maybe you're going to call this My First Experiment or Processing 101 or whatever it is. And that will go to the Documents folder, the Processing folder in Documents on your computer.
So Jeff's going to open up a new one.
Grab a new window.
And we're going to add our void setup and void draw just like before.
I use a style guide that's in some places considered uncommon, I guess.
Bad form.
Bad form. I do it because I'm really dyslexic and I like line items. So your style may look different than mine.
So mine and Jeff's look similar because Jeff taught me, for one, or got me started. But I also do it so that, like when I have a single character or single object line, I like to put it on its own line so that when I'm teaching, and those people that I'm teaching, if they're missing something, it's very clear when I walk up to your computer. If it's, because the normal, so can you do what would be standard syntax for a curly bracket, the open one at least? So you'll see that it actually starts, the open curly starts up here in a lot of places, and then the closed is where it is normally.
So as we get into these functions and creating functions, there's going to be a lot of curly brackets floating around and a lot of stuff going on, and I want to know that stuff's native, that I have opened something and closed something, and how do I do that? And you can see that I clicked in the draw function, I clicked on the bottom one, and it squared out the top one, and that means those two are native. It's looking at those two as a pair. It's a handy tool.
So he's going to move his curly back down, and in void setup, Jeff, can you give me a white background? So a single digit white background. So Jeff's going to type in background. Instead of the 3 RGB values, he's going to use grayscale. So grayscale is if we just gave it one number, 0 to 255. 255 being white, 0 being black. Oops. And of course, I forgot size. So I have a white background, and I'm going to hit play, because I'm going to test it out, make sure it works. Okay, I got a white window. Good to go. And I'm not going to put anything in void draw right now. And I'm going to go below void draw. And I'm going to type void mouse drag. And then D in drag is capitalized, or it's called camel case. It's a way of jamming two words together, but making them two words still. And open, close parentheses. And it's going to have its own set of curly brackets. So inside of my mouse drag, so I only want, so drag is like a click and hold and me moving the mouse. So that's the definition of drag. I'm going to create a line. When I drag this mouse, I want to be able to draw something. So I'm going to type line, open, close parentheses, semicolon, and I'm going to put in the line mouse X, comma mouse Y, comma P mouse X, comma, you can probably guess it, P mouse Y. And Jeff's going to hit play. And now he's going to click and drag, move our mouse around. And we now have a really quick, joinkity drawing program. So what if I want to make that line thicker? Drag slower. There's a function for that. So instead of an app for that, there's a function for that. So above my line, I'm going to type stroke weight with a capital W, and it's weight like packing some pounds on rather than weight like I'm waiting for the bus. And the number I want to put in stroke weight is the width I want of that line in pixels. So Jeff's going to put 5 in there. Yeah.
So when we set like the stroke weight of Pokemon or something, I mean that's just whatever we draw after that until we change it is going to inherit that.
So yeah, I'm going to get there. So Jeff's playing around with it, different weight, pen thickness.
You guys are on the internet, by the way. We're streaming this class.
Yes, ma'am. You have a weird thing. I love weird things.
Good. Then you're doing something right.
Whoa! Oh, because you have P mouse Y, P mouse Y.
Ooh, I like that.
But I didn't like that's.
That's super cool. Do a scan like that? Can you scan somebody in profile? Right? Okay,
So, question was about like, if I want to, what I call modify this line. So if I want to change something, if I want to fill the color of something, if I want to change it somehow, the modifiers for a shape happen above that shape. So another modifier for a line is the stroke function. So just stroke. Some days I feel like I'm going to have one. And you can give it an RGB value, or you can give it a grayscale value. You would treat it just like you would fill or background color. So for this, so Jeff's going to do a green line.
Do you want to do something different?
We'll change it, but do green line first.
Okay.
Yay! We're gonna use random. So again, weird people doing weird things with software. We're gonna go a little psychedelic here. So we're gonna use the random function. So random is kind of creating a variable that's gonna give us a random number. So Jeff's gonna type in random, and it has its own set of parentheses. And inside of those parentheses, we're gonna put 0, comma, 255. So we get this kind of random grayscale line that every single frame it's going to change to different shades of gray. Yeah.
So are you saying that if you just use 2 parameters in your stroke,
So this is one
that's
parameter.
just grayscale?
Yes. So just
These
one.
are the brackets. Says you can start at 0 and you can go to 255, but don't give me any numbers besides 0 to
I'm sorry,
255.
if you're just giving it one parameter within stroke, it's a grayscale.
Yeah, it's grayscale.
That's right.
And if you give it 3, it's RGB.
Yep.
Unless the one is hex, and then it's.
So we can do 3 randoms.
Yeah. So Jeff's going to copy and paste random 3 times,
Got it.
and it's going to be 3 RGB values. Yeah.
And is any of those numbers being 0 and 255 equally likely?
It's a software random function. We could go into the, the like qualities of its randomness, but that's
But it's
been.
intended to be with it.
Yeah.
So you could, there's a random seed you could use that makes it a little bit more random, but for sake of just random color.
They're supposed to be uniform.
Supposed to be.
So now we have this kind of cool multicolored line. It always reminds me of, you know, that, I can't remember exactly what it is, but where you put color down and then you have like the black wax and you scratch the wax off type art.
Resist.
Thank you, Jim. So, we're going to give it another function. Key pressed. So we're going to give it another event function, and we're going to do key pressed. So void key pressed. Because we want to be able to, when we draw something, we want it to be, we want to be able to erase that. Nope, do it, keep doing it. Open, close parentheses.
Right, sorry.
It'll change on it. So, void key pressed, and we're actually going to put in that void key pressed the same background function that we have at the top. So we're going to do background 0. So before Jeff hits play, when he launches that, he's going to open up a window. It's going to create a white background. We're not going to draw anything in that. You jumped the gun on me.
Oh, sorry.
And then when we drag the mouse, it's going to create a random stroke color and give it a stroke weight. And then it's going to draw that line. And then when Jeff presses a key on the keyboard, it's going to redraw the background at white. Actually, it should be 255. So, let's see if that works. Ta-da! Cool. Do a weird stuff with software.
Doing weird stuff with software.
So can you bring back the slideshow again?
John, what are we doing?
Slideshow.
Slideshow.
So we have all of these options. You know, mouse click is just one click, and it's a computer, so it's a little dumb. Okay, computers are dumb until you tell it to do something. So, like, it takes a lot of these very literally. So you kind of have, if you have a specific function that you want to have happen or to trigger something, you kind of got to play around with some of these things. Like there's key pressed versus key typed. I couldn't tell you the difference between the two. Other than maybe key typed is looking for the release of the key versus just being pressed. But to our eyes, it's the same function. Cool. So there's a whole bunch of these in the reference. You can play around with them. We're going to be using the key press because we're using the hardware we're going to be using is the makey, which breaks out keys. So we're going to be using key press a lot. And we're actually going to get into that pretty quickly. So give me the next slide. Again, that event function structure of setup, draw, and then some type of event function. If we're communicating serially, so with Arduino, there's actually a void serial communication event function, which makes serial communication visually smoother. Yes, sir.
So do you, whenever you're writing do you always have to have void setup and void draw?
Yes. So void setup and void draw have to exist, but you don't have to put anything in void draw.
Okay.
Then the void call at the bottom is like a subroutine. It's like a little program that we put aside and we go, this is only going to run if we do a certain thing. It's like an if statement that lives outside of the standard draw.
If we remove void draw, it would run, but it only run once, which is a 30th of a second. And just so we tend to teach so that people leave the void draw there, just so that you have something to be able to structure-wise. It's just nice to have there. Okay. Cool. Yeah. So we just did this quick drawing program. And then, so we're going to start playing. We played around with just the basic shape, right? We've been able to move a shape around. We've been able to do, have a shape move on its own. We're now going to start looking at groups of shapes. Because if I draw a snowman, for example, that's 3 circles, and then 3 circles for buttons, and a whole bunch of lines for stick arms, and a triangle for a nose.
All of these shapes, if I wanted my snowman to move back and forth, that would be a coded nightmare.
So what we need is one reference point for all of those shapes. Now, there's plenty of ways that we can do that. We can make it an object class and go kind of crazy with code, or we can kind of do the hot way of doing it, which is the way we teach. And it's using what's called a push and pop matrix. So again, think of in terms of that collage concept. It's like taking that snowman collage and putting it on its own piece of paper. And now I can move that piece of paper around rather than have to move individual pieces of paper. So we're actually going to open up a whole new sketch. I like to teach in these small sketches because then you can come back and reference just little bits rather than have to tear something apart to figure out what it is. Void setup, void draw. And what I'm going to have you guys do, because I want us to spend some time just practicing, draw something simple. Draw a snowman, a little kid's drawing of a little toy truck. Create something out of a group of shape functions. So triangle, we could try triangle, but ellipse, square. A snowman's a pretty easy one because it's just a couple of ellipses. A smiley face is a good one. So we're going to draw. I want you to spend 10 minutes. Just draw something that you want, and we're actually going to play around with how to move that. And again, you got the graph paper, so if you need to kind of figure out how to draw it, and if you need help, let me know.
Are all the shapes referenced to their center point?
No, so a rectangle is the upper left-hand corner of that rectangle. An ellipse is the center point. So an ellipse is the center point of the origin.
If you give the ellipse only 3 parameters, will it default to a circle or will it fail?
I think it'll fail.
It'll kick you an error.
Hey, did he use the matrix in the hippo?
I don't know. Well, I should load the hippo soon.
Just to give you a preview of what's going to happen, you're going to experience some frustration. Just to let you know. It's also one of the reasons why I'm asking you to draw something simple. I'm liking the bus.
You like the bus?
Liking the bus.
The bus lends itself to movement.
You could do that scratch animation of the fan bubble. Need a couple more minutes. Don't worry, because if you don't fall in love with it, you'll be happier in the long run. So if you wanted, so Jeff, don't hit play yet. So if you wanted this to be a different fill color, so you'd actually put a fill between.
So it only goes with the flow.
Yeah, so this fill will fill everything below it unless I put another fill function.
But it's a loop, so they're coming back around and fill the stuff together.
Yeah, and so that's why if you have something halfway down that you want to be filled, and then I tend to group my shapes with my modifiers. So like for the way I would structure this so this fill right here, I would actually double bump this down so that these ellipses and this rectangle are visually separate. So that as I'm looking at things, I can see how I'm modifying which shapes. What?
And build the windows with a reference function?
No.
No.
Let's say 2 more minutes while Jeff figures out his window X and window Y. We don't have transparencies in here anymore, do we? It's okay, I'll use the slide. I have a slide of it. No, leave it. Leave it. It's a wonderful special bus. So Jeff's got his fun drawing here of the bus. Looks kind of like a whale. Put tail on it. So what we're going for is now some way to group all of these shapes together so that they are one, they act like one shape. And what we're going to do is put them in a matrix, meaning put them on their own set of origin, give them their own origin, be able to move them all as one piece of paper. So we have to put a function above and below the shapes we want to use. And here, being a teacher, I always come up with really weird ways of getting to remember things because people always get them mixed up. Because there's push matrix and pop matrix. People go, which one goes first? I forgot. So being a teacher, I'm dealing with kids that are always fighting. What usually starts a fight? A push. And it usually ends with somebody getting popped. So what goes first is push matrix. So these are the groups of shapes and modifiers I want to keep. So I'm going to say push matrix with a capital M. Open and close parentheses, semicolon. There's nothing inside the parentheses for this function. At the very bottom, I'm going to put pop matrix with a capital M. So now we have a group of special modifiers that we can use with this matrix. We can use them without them, but it makes more sense to use them inside a matrix because usually when you want to move a whole set of things is when you want to use this, or if you want to scale something down, you want to use it. So actually above this fill, so we're going to bump this down to the very top, so we're going to put translate. And if you've used Photoshop or any type of those photo editing or imaging software, you usually have these set of functions that are like transformations, like translate or scale and all these other things. That's what we're going to be looking at, that type of stuff. So translate is another way of saying that we're going to move this a certain direction. So for Jeff's bus, because the bus is going to stay on the road even though there's not a road to drive on, we're going to put mouse X, comma, what's the bottom of your bus?
My bus is 200.
So comma 200. So now when Jeff hits play,
No, I'm sorry.
oh,
200 plus the wheels, right? Plus half the wheels, 220. Got it.
so now that whole bus acts as one shape. Could we have Jeff's bus bounce back and forth now? Yep. So we're going to move the background so that it's not leaving bus tracers behind. Cool.
And where's the anchor point for the matrix?
This is that remember I said there's a frustrating moment coming? So the matrix has its own origin. All right? What we translated was not the bus itself. We actually we're moving the matrix itself. So we're moving it to mouse X, and we're moving that matrix down to 220. And I've got it's actually a really good picture of it on a slide here. So we're going to go into rotate soon. So you'll see the frustration point. If you wanted something to rotate in place, it's not going to work because it has to be at that origin for it to rotate. It's going to rotate around that distance. Oh.
Sorry.
Keep going and then skip the system conditionals. Keep going. I have it somewhere. Maybe I don't. There it is. So normally we think of it when we translate something as we're moving that shape. Moving it from this point to this point. But we're actually moving this whole grid to that point. Now imagine if I've moved this grid and I try to rotate that, or if I want to rotate this object on its center, but it's not going to happen. It's going to do something like this. Let's try it with Jeff's bus. So we're going to, instead of transform or translate, so we're going to comment out. So again, we want, instead of deleting this whole thing, we're just going to put those comment lines right in front of the line of code. So that we save it for later if we want to use it. We're not deleting it. We just comment it out, and what that does is the computer's going to skip over the top of it. And right below translate, we're going to type rotate. So rotate, normally we think in terms of degrees, right? Or humans, we usually think in terms of degrees. Rotate is in radians. And here's a really easy way, if you haven't learned this yet, how to translate radians into degrees. So 0 is right here. And this is pi, or we could say it is 3.14. So 100 degrees equals 3.14 radians. 360 would be 6.28 radians. 90 degrees is half pi, and you can actually do, so pi divided by 2, or half of this, which is 1.64, right? Yes. So pi is actually a built-in value in processing. So if Jeff wants to rotate his bus 90 degrees, he can put in capital PI. Actually, it's half. So all caps, half. Underscore. Or underscore. Half pi. You could also do PI divided by 2, or 3.14 divided by 2. It's all the same value, but this is just... So now if you hit play, let's see if your bus is still on the window. So it's actually rotated off of this window. So just do rotate, let's do like...
I'm going to do pi divided by 10.
Sure. Because remember, it's rotating from that different origin point and not the center of the object. So now his bus is careening down a hill. No brakes. And if we had the little draw tool we made, we can make flames. Flaming bus. So if you're planning on drawing something and using this, the matrix tool, unless you're just moving something up and down, left, right, you want to start out by drawing something at that origin point. If that makes sense. So you start drawing, like if I drew a snowman, if I wanted to draw a snowman, then I wanted him to be able to rotate around his belly button, essentially. I would draw a snowman that actually started like that, and then I would translate it to the middle of the screen. Then he would rotate around this point. If that makes sense to everybody. We can scale. So again, we're going to comment out rotate, and we're going to put scale. And scale is in the decimal form of a percent. So if I want something half size, it'll be 0.5. If I want something 1.5 times bigger, it'll be 1.5. Jeff, give me whatever you want to scale your bus to. There's this micro machine bus. But since I scaled not just the bus, but the whole matrix, it scales down that way. So it's getting smaller in the X and Y. And it also scales things like line weight. It scales things, obviously the shape, but the line weight is the thing that shows up. So if you put mouse X divided by, so it gives you kind of a, Yeah. So mouse X, and then divided by something so it stays in your window. It's got to be a bigger number than 2. There you go. So if he scales it up, you can see that the line weight gets bigger. So it's scaling everything up. So here's a question for you to think about. What happens if I take something and I draw something outside of this matrix? Yeah?
It becomes its own.
It's its own thing, right? So if Jeff draws some type, maybe a brick wall that his bus might run into, so a rectangle, tall rectangle in front of the bus. So outside of this matrix, so below pop matrix, so he's outside of it. He's just going to draw a rectangle or a line, and we'll see what happens. So now we can scale and do a whole bunch of stuff with something else, the bus, and that line stays by itself because it's outside of that matrix that we're manipulating.
I like the bus better with fatter lines.
Me too.
Less of mine.
So we're going to drive this object. So we're going to add a little bit of code to it. So we're actually going to add an event function. So we're going to leave, let's create a we're going to create top variables called x and y, really creative, right? Int x and int y. Yeah, so initialize them to like 200, 200, or 200, and y would be 200 as well. So what we're going to get, our goal for this one is that we're going to use our arrow keys of our keyboard to be able to get our object to drive right and left and up and down. So we're moving this matrix using our arrow keys. So at the very bottom, again, we're going to put void key pressed. So we've used it already to erase our line. Now we're going to use it to do something else here. And inside it, we're going to put an if statement. It's actually going to be a series of if statements. So, but the first one is if key pressed, and we're not putting parentheses after it, so it should turn pink. You don't have to put true. So you're going to say if key pressed and.
Okay.
So we're going to say if key pressed and. So and is double ampersand. Key should turn pink equals double equal sign coded all caps. So there's, on your keyboard, there's two different, I guess you could say, types of keys. Your letter and number keys and some other keys have what are called ASCII values, so they have a number associated with them. And then there's some keys that are coded. meaning that like your up, down, left, right keys don't have a number associated with them, they have a code associated with them. So what we're going to be doing, our if statement is looking for if a key pressed, so if a key is pressed, which is true, and that key that was pressed is coded. And we're going to put inside of this if statement another if statement. So we're now starting to nest some if statements inside one another. So inside of this one, and see, this is where Jeff was talking about making sure everything has its pair. Because look, we're starting to pile up a lot of these curlies at the bottom. Hey Jeff, do you want to bump down so this kind of moves up so people can see it? Okay. So Jeff's going to give us some space so that it moves up here. So we're going to say if key code, and it's key capital C code, double equal sign, up, all caps. So if this is true and this key code is the up key, what do we want to have happen? If we want our object to move up, what do we have to do to its x coordinate or y coordinate? We have to subtract it. Now we can do the y equals y minus 1, or we can just say y minus minus. Meaning it's just going to decrement y. Semicolon. So just like we're going to hit play and test it out. Where's the... Let's get rid of the scale. So Jeff's going to comment out the scale part of this. And he's going to bring back translate. He's going to put x and y inside the translate. My apologies. So now if Jeff presses the up key, his bus floats off the ground. Try pressing any other key. Doesn't work because we haven't told it to do anything yet. So we had to program in the other three keys. So we have this if statement. Jeff's just going to copy and paste it. And it's going to be, again, nested inside of that first if statement. He's going to change it to down. And he's going to change it from minus minus to plus plus. So we want y to increase or go down as we press the down key. Test it. Make sure the bus moves down. Bus moves up. Jeff's going to be smart and he can copy and paste the two if statements that were inside there. Change one to left and the other one to right, and then we're going to change the x values for left and right. Good. Change key code right. Yep. careening in
If you hold two of them down, it doesn't.
Yep, because
it locks in the
it'll only do one. So you actually have to, if you want something to move diagonally, you have to create 4 more if statements with a compound key code if statement. And then like, so if you want it to move diagonally up to the right, it's decrease y and increase x, and then it gets a little, you'll get the hang of it. It's just kind of taking what you have and duplicating it. You want to go over makey makey? Because I think it's a good time to do something physical.
So when you say if key pressed.
Yep.
So if we stop there, any key you pressed, it would enter that subject to
Yep.
that. When you say and key is coded, what is that referring to?
So key coded, so there are 2 different types of keys. There's ASCII value keys that have a number associated with them, which you can use if you just use key. It actually counts as a variable from your keyboard values. Arrow keys, the enter key, the shift key, and the alt key, I think escape too, is coded. So it doesn't have an ASCII value associated with it. It has a specific code. So you're saying, if a key's pressed and that key's coded, do this.
So the coded keys are a subset of the keys, and within the compiler, it is assigned these text labels to the forest.
Yep.
Why do we call that check when it's just called if key coding goes up?
If key coding, it doesn't work. It could work. I mean, it's just a way that I type because I want it to be checking if it's keys pressed at that time. Because if I'm holding it down, it's kind of the nature of a event function versus an if statement, because they're not checking it exactly at the same time. Huh? Jay and Eric? Yes. We can show the video. It's actually on the presentation. Right there. So this brings in, so at this point, you now have the ability to use the hardware in front of you. It's kind of why we're stopping here about 40 minutes before lunch, because what the makey makey does, if you haven't seen it, the video is going to tell it actually breaks out keyboard keys to hardware. So now you've gotten to the point of processing where we're going to start incorporating hardware a little bit. And I'm going to let the video speak for itself.
Just by alligator clip. Alligator clips stuff like bananas to your makey makey. When you touch the banana, your computer just thinks you're touching the keyboard. The front has arrow keys, spacebar, and mouse left click. When you're ready for more, let the makey makey over, and you've got 4 keyboard keys that support for the mouse. You can give it this support like when you are ready. No program, no breadboard. You don't even have to install software. Just plug it in with USB.
Recording our makey makey today can start changing how the world works.
bust open those boxes and plug the Makey in. So one of the ways I'll test this is to make sure that your individual computers recognize this, is once this is plugged in through the USB cable, we should be able to take the alligator clips, put a green alligator clip along the bottom row where the earth or ground symbol are right here, and another one in the space bar. If you flip this over, it'll be marked space, and you can check to see with a word processing program if you're actually getting space by touching those two alligator clips together.
Let me get a pair of scissors for the baggie.
Oh, right.
Forget we have hard stuff. Every person doesn't like to use your teeth to open up plastic baggies.
Did I miss a board? So Makey was a Kickstarter. Jay and Eric asked for, I think, $25,000, and they got like $250,000. And it turned SparkFun upside down because we were making the first batch of Makeys. And for weeks, like all anybody ever said here was Makey.
So I'll just say that was pretty funny.
I was gonna say that was.
I don't think I've ever plugged in a piece of hardware and.
Did you guys watch like the whole thing to transpire?
The whole thing?
Well, no, like when they made this and went Kickstarter with
No,
it.
I've done that, this, I just plugged it in, it's like his head's a space geek now, I mean, this is cool.
It's amazing. It's really amazing. Well, what we found is that it's so expansive that this piece of hardware, because all of a sudden the keyboard becomes like an interface to programming, is that I can clip a piece of copper foil and run it from here to my office. And if somebody's grounded and touches that anywhere along that, it's a key press. So all of a sudden the room is a keyboard. We did a workshop in Ohio. Okay, so if I take a piece of copper tape and I run it from here to my office and I clip it to the space bar, you know, I clip one end of the copper tape. Anywhere along there, if I run a second piece of tape next to it, and ground it, clip it to ground it, if I step on that with my bare feet, it's a key press. So the whole room is now a keyboard. It's really, I did a workshop in Ohio with a group of women who were working with kids with severe disabilities, some of them who couldn't move any part of their body but their head. We ended up making pillows that these kids could touch their face to part of the pillow and move the cursor on the screen. So now all of a sudden it becomes this tool for accessibility. I mean, there's just so much stuff that you can do with it. We see people do musical instruments, and God, all the library people are like, they're rocking it really hard. They're doing great programs with kids and Play-Doh and fruit.
So the number one babysitting thing that for my kids, so he's 4 now, but he got a hold of a Makey at 2.5. And I take the Makey, plug it in, give him a bunch of Play-Doh, some pieces of silverware, and some like strawberries. And he'd sit there and I'd clip the fork and knife to the Makey for him, and he would stick some in the Play-Doh, and he'd be like banging on the Play-Doh, and it's playing piano music. And he just, I mean, it's 2-year-old prototyping in hardware. And he'd make up his own stuff that I'd never think of.
So Did you guys got rolls of copper tape? Did you get rolls of copper tape? So I think I'm gonna do like a brief prompt.
Go for it.
And I may borrow, Angela's like memorized the cap.
Here's some big stuff.
Okay, so, so the copper tape, I love the copper tape because you can then take and make paper controllers out of it. There's got two of those. Okay, cool. So if I take the copper tape in there, and I just take an end of the copper tape and peel back about 2 inches of the backing and fold the copper tape back on itself, I now have a nice thing that I can clip to. And I can take that tape and put it down on the table. And do another piece parallel to it. I'll fold back 2 inches. And then I clip ground and whatever else on there I want to use, and I can change the key code. I'm going to grab it.
I got one on that desk.
You got one on your desk? Great.
So the basic concept of this, while Jeff's getting set up here, is that you have an alligator clip hooked to earth or ground. And then you have all these other alligator clips that you can clip to these different. And when these touch, it's the same thing as touching that key or pressing that key. The cool thing is, I can clip one of these to a banana, or an apple, or Jeff. And then when I touch this to that object, or if I'm holding this and then I give Jeff a high five, it completes this circuit. Completes that loop. So the whole concept of what you want to do is that you want to create all these things that are recreating these keys, but then when I touch, when I complete the circuit, it's completing that key. So Jeff can move the slideshow back and forth now and make naked.
So if I'm going to go back to the processing sketch.
Yep.
And if I run this, there goes my bus by touching my makey. So if I hold my hand down on there, my bus moves up.
So the video, are they ground when they're playing like the banana phone? Are they grounding themselves and then they're touching each other?
So when you make like a video game controller or something, yeah, so like you have it hooked to your ring.
Right.
A lot of times they'll make bracelets.
Okay.
So I usually, you have to be kind of careful when doing this because this tape's a little sharp. But I'll take the tape and I'll turn it inside out and then stick it to itself so that I have like a copper tape bracelet and then clip to the copper tape so that I'm grounded and I can be touching all of these different keys or bananas.
Stretch conductive fabrics, right?
There we go, stretch conductive fabric, which we do have, so.
That's weird. It's pushing up unless
The edge of the table conductive?
Could be the metal, could it be metal on the tabletop? Good question. It is, that's good eye.
It's this strip right here, yeah.
So for this class, the goal of this class was to get you familiar with software. So get you familiar with coding and processing and being creative and prototyping in software.
But then give you a piece of hardware that you could prototype with without having to do code in both places and learn circuits. One of the things that I would say would be kind of your next step after this class would be to take our Intro to Arduino class. Shameless plug here. Because this is an Arduino. So you can actually reprogram the Makey and have it be an Arduino. But you also, once you start incorporating the Arduino, now you get data from whatever, temperature sensors, light sensors, all that fun stuff. But we wanted to give you something that's simple, easy to use, and you can start playing around with while focusing on the software side of things. And then once you get going with that, you can jump into our Intro to Arduino class and start programming the hardware side of things as well.
So I got bananas because I can't resist. You're not supposed to eat them. No. You have one of your peels. So I'm going to use the banana peel. So this is a capacitive touch library. So it requires very little energy to move through the circuit. Absolutely safe. Where was I? I was someplace really organic.
I'm gonna shock myself.
Everybody says, they all say that. Somebody said that to me. I went to present on Makey somewhere. I think it was in Vermont. Some overly concerned parent said, is this safe for my child? And I was like, yeah, of course it's safe. And she said, it's electricity. And I'm like, yeah. And she said, there's electricity passing through my child. I'm like, yeah, but it's safe. And she's like, they all say that. So now, I've got my up and down, and there goes the bus when I touch the banana peel. So I got ooh, I didn't even need, did I need? Ooh. Boy, there's so many combinations you can do with this. I didn't even need the ground. I can just touch both the banana peel and the ground strip, or this and the ground strip. Or Derek can be my left arrow. But is it safe? I'm going to pass some electricity through Derek's body.
Which has been a lot more electricity passed through the body.
So
now you can prototype a video game controller. You could. What else? I don't know. Like it's almost so expansive that it's hard to give reasons to do so.
here's what I would like to see. Is I would like to see by lunch, we got about 20 minutes till noon, we break around noon or whatever. Can you change the size of this and have it locked? Store the size to a variable and increment or decrement that variable from a key press and makey. There's the prompt. So you can start with a shape. Let's just say I didn't want to do all the movement on the translate on this. I could start with rectangle or ellipse. How do I change the size of the shape of that? By storing a number to a variable and then increment and decrement based on a key press and makey. Should I walk through it?
And I
Now
would
we
do
do
this
this in a new sketch.
So I have to keep
New
this one,
sketch.
save it, do a new sketch.
So I think, do we code along with Jeff?
Code along with Jeff.
Code along with Jeff. So I'm just going to grab new. Start with my standard voids. I think I'm gonna start with some variables up above. We're declaring these variables as global variables, which means they can be seen from anywhere in the program. I don't necessarily have to declare my variables at this point in time in the program, but this is the most expansive way that I could use that variable. If I only needed to declare that variable and I didn't need it to refresh, which means that I'm not burning cycles in the program, I could declare it in setup once. It gets declared, initialized, and then if I needed to change stuff later on in the sketch, I could do it in setup, but it doesn't use a computer cycle as it goes through. So this is a nice way to store stuff out and not have it be using memory cycles. But I'm going to declare them up here. I'm going to say int x value, and I'll call it xval equals 100 semicolon, and then down here I'll say int yval equals, I still always start 100, 100 because I'm a really decimal thinker. And when I start with program, I start with stuff that visually, like, because I'm a 10-based learner, I start with things that I can like kind of see in tens, but that's just me. So I'm going to give it a size. Down here, do I want my background? Yeah, I'll do my background in the loop. That's pretty nice. Right arrow? No, mouse X, mouse Y. We'll start with mouse X. Dyslexia. Let's just run far so good. Okay. Now I want to change the size. So I'm going to do an if statement in the loop. I'm going to say if key pressed we have a different syntax for this time. And key coded. Coded all caps. Sorry? Yeah. If I use Control T a lot to format my code. It's a built-in function. Gives me all my tabs and margins. If key equals up. Thank you. Let's see. There you go. Yeah.
And then maybe you can use 2 more keys to rotate it.
Okay, so I'm growing it in the X coordinate by touching, moving it with the mouse. Okay. Stack another if statement in here.
So one of the cool projects I had students do with this was that I took a stranded copper wire, I frayed it out so that it made kind of this brush-looking thing, and I put a pendulum in the middle, so that it went back and forth, and the pendulum is connected to the ground, or earth, and then there's 2 key presses of left and right. And so, as the pendulum would go back and forth, the wire was light enough that it wouldn't impact the swing of the pendulum enough. And so you'd start getting this thing to move back and forth according to the period of that pendulum. So it kind of plays into like changing how you control things on the computer screen. You know, something that I built is now controlling what's going on. And you can even, that mouse X and mouse Y value, if you flip the board over, you also have a breakout of the mouse being moved up, down, left, and right, and the mouse clicks, as well as some letter keys. So if you want this to move, instead of having to give it, excuse me, so if you wanted to move this point, even with the code it has now, you would just complete the code using, there's little jumper wires in there. You can see that there's little logos on the back that have the mouse moving up and down, left and right. So now when you can connect those to ground, your mouse will actually move to the left, or right, or up, or down. And use the smaller jumper wires to do that, which are these guys. So then you can alligator clip to those. You can really freak people out too, because they're looking at the mouse, and you're like, the mouse starts moving. So Jeff's starting a new function, and it's a visual addition, and that is the text function. So we can actually write text on our screen. And we're going to get to manipulating the text a little bit more in the afternoon, but general text, it works this way, where you pass it three things. You pass it the string of text you want to show, and it needs to be in quotes. So Jeff is going to put going up, and it should turn purple, and it's in quotes. And he gives the X and the Y value, so you have O's instead of zeros. Gives the X and the Y value of where that text is going to be. And he's going to do text size, capital S. And again, that's height in pixels. So it's not its actual font point size, but it's its height in pixels. Wow.
What's that?
It's going to be huge.
Is it going to be huge?
Then when he lets go, it disappears.
So now I can pull that function. And this is nice, but I want it to be a color, right? So, Derek, help.
Phil.
Huh?
Phil?
Phil, that's right, yes, thank you. I forgot whether it was text.
What Jeff's asking about is that some things react to fill, and some things react to stroke. And text is one of those things that's like, we treat it like a line, but it's actually a shape that's filled. So fill will work for text.
Anyone wants any orange peels? I've got a box full. Okay, we'll keep doing that orange.
So if you watch, so you guys saw Jay, he also gives a TED Talk where he talks about Rodeo, which is the predecessor kind of thing to, it's a sound making device that you draw while it makes noise. But he also talks about makey, and my favorite key item that he uses is actually pieces of pepperoni pizza. Now it's like the grossest thing ever, because you're like, but it's awesome for a presentation, right? Like, I'm controlling my computer with a piece of pepperoni pizza.
So I did a workshop with Jay about 2 years ago. Actually, I didn't do a workshop with Jay. I did a workshop where Jay was also doing a workshop in this open space at Queens College. And Jay's insane. I mean, Jay's literally insane. He's the most fun human being I think I know. But he's also really, really difficult. And they showed to work with, because he's such a show person. They showed up with 2 bags of groceries, and they took over this lab, and they just built this whole thing with fruit and bottles of soda and just like all this stuff, and they were so creative with it. If you get a chance, is he still on? He's not on Intel? No. You'll see Jay at Maker Fairs and stuff. If you get a chance to do a workshop with him, it's worth doing. So I'm going to change this. I'm going to move this.
magnetism. Go down.
So, yeah, sorry. Derek, if you're doing a data collection, not with making with processing, you're reading your own, say, a value from an Arduino. Are you limited to that 30 frame, that 30?
So you can actually change the frame rate.
Okay.
But if you're doing serial, it's just passing data and you're parsing that data as it's coming to you. I haven't really run into a frame rate issue with parsing. At least to the quality that
That's independent of that frame rate, just a display frame rate.
So that's just for draw.
Right.
So if you're pulling data using the serial event function, that's as it's coming, it's holding on to it.
So when you call data in a serial function, you give it a speed at which you're pulling that data, 600 bits per second or whatever, and then that data will get delivered at that speed. The refresh rate of the screen stays the same.
Yeah, I was confused. I was thinking the frame rate was the program run rate, which it isn't. It's just the display refresh.
It's just the display. Yeah. And for all intent and purpose, we've run some pretty good stuff with that 30 frames a second refresh rate. So we did, yeah, I'll show some projects with it. We've noticed some latency in video.
Yeah.
A little bit of latency in video.
That's also was tracking the quadcopter.
So, that puts us almost right at lunch.
I think it's a good time to go eat lunch and then bring back food to like play with making.
So, So here we are, and if you go down, there we go. Did everybody bring lunch? Does anybody need to go get lunch? Yes? Okay, all right. If you go out here, go out to 63rd and you turn on the spine. Right here in Gun Barrel is a King Soopers. There's a delicious Burger King, a Subway. And across the street is a Quiznos. There's also a coffee shop there. Who makes grilled cheese? Really? For the vegetarians?
You just changed my rock my world right there. Gained 10 pounds and I'm blaming it on Angela.
So those are kind of the options right there. We'll break until 1 o'clock and come back.
Yep.
We're here if you're inspired, play-minded. We're not kicking you out, but you should eat a healthy, balanced meal.
Cool.
I found out that it's like using, I gave it a SparkFun. It is SFE.
You just have to show off.
Oh, awesome. Oh,
So
nice.
Bitly, the Bitly address. And then
That's cool.
This is really cool, because, I've seen it on your website for however long you've had it, and I thought,
Whatever.
whatever, right. And as soon as I plugged it in, and didn't have to do anything, and it started playing, I was like, oh, I get it now.
The other thing is like for Halloween,
Oh, yeah.
you wire the house, kids touch the door and stuff happens.
Oh.
It's just, there's,
That is cool.
Yeah, I know, it's actually, huge amount.
So you do it.
Mike, did you bring lunch? Do we need to get you food?
I'm good.
Any comments on the web? Nothing?
Nothing specifically expected.
Just pick those guys up for me.
No, that's all I got. So this one we're seeing is listed. Okay, cool. Very good. What did you hook up over here? So, for the snowman we did earlier, this is zoom in, zoom out. This is called really.
Really? it's going back. So I'm using XB wireless. So I'm using these. This is 2.4 gigahertz wireless. So I'm using this. I could send this to a phone if I wanted to. But we use these Arduino Theos, which are a combination of Arduino and wireless socket, and they're super handy for prototyping. Like it's kind of become the go-to chip for us on a ton of stuff. Because you automatically have a wireless function. There's no, I mean, it's plug and play, load the code on there, boom, you're done. And I don't know what a Theo is these days, but it's not much more expensive than a regular Arduino.
For your field apps thing, are you using an external antenna or is it a little,
So this has got a wire antenna on it. When I usually go to longer ranges, I switch out from 2.4 gigahertz to 900 megs. The 900 megs, yeah, Derek's got, these are the 900 megs units. And the 900 meg XSC units are good to 28 miles with a Yagi. I've done 2.4 Yagi stuff in my neighborhood and gotten 8-mile range out of 1 milliwatt.
that's a ground.
That's a ground
You
level.
put it on balloon
You put it on balloon, but I mean, 8 miles with all the noise in my neighborhood was astounding. So we took one of these over the summer. I did this thing with a guy from Tusk. So we're using these balloons as like steps to space in terms of science curriculum. And here, I'll just pass this around. We gave my sister one of these packages, sent her out on our property back east and said, go hide this. Put a Yagi on the XB, shot the Yagi, picked it up. It was buried under a pile of leaves, we still found it.
Yeah, same way I found Rogers. But do you use diversity or are you tracking?
So what I do with the XB is because the XBs have a received signal strength indicator, but when you get to within a certain range, you're just drowned out and you don't know. So what I do is I put a piezo buzzer on the receive line, and I go from looking at it, like I can pull this up and look at flashing lights and go, all right, I'm getting signal here, but I'm not getting signal here, so I know it's in that general direction. And then go from light to sound, and you can actually hear it as a tone.
I changed gears. I mean, for your telemetry, when you're out at 20 miles with your balloon, are you tracking the balloon with your directional antenna? Or you have multiple antennas and a diversity receiver so you don't have to track?
So I haven't done that kind of range on the XPs. When we go out that far, we go to 2 meter or 70 centimeter. I'd like to. One of the things I want to do is move up from this. This project's really new for me. What we want to do is we want to bounder. We're working with automatic cut downs on the balloons now. So let's say I say at 4,000 meters, I want this thing to release the payload, and it comes down on payload or on parachutes. So we're experimenting now with sending these balloons up and doing automatic cut down and doing predictions based on weather mapping, and then going and getting them. I want to play with XP to see how good that is moving out before I lose payload, because we have a rather sordid history of losing payloads.
It'd be cool to have bi-directional so you could cut, if you see your winds are off or 100 knots or something, you could cut it down before it goes to the next state.
So if you look up Still David ballooning, there's a description of a launch we did in the White Mountains in October where we did an automatic cut down based on the weather and landed it, I don't know if you know the East Coast at all, but about 10 miles south of Mount Washington. So we looked at where we were in Bethlehem, New Hampshire, and if we had gone full burst, the payload would have been in the Atlantic. So we did this projection based on the wind speed at altitude and how fast the balloon was going up. We said we want a 4,000 meter cut down. It gave us this lateral distance of around 15 miles. Because if we cut down on this side of the Mount Washington range, it was all, so we could get to areas by road. On the other side, it was the other side of the New Hampshire-Maine border, and there's nothing. It's trees and lakes, and there's no roads. You can't get to it. So we projected that our cut down would be around Crawford Notch, which is kind of relatively easy area to get to. We were a mile off where we wanted to put the balloon. Unfortunately, that mile meant the difference between picking it up on Crawford Notch and climbing the mountain next to Mount Washington. And it actually landed pretty much on the summit cairn next to the mountain, on top of the mountain. So it was, but, so we're still working on it. I mean, this is all like kind of new stuff, and you know, we're trying to figure out how to get this weather balloon, whether it's tethered, free flow, automatic cut down, all this stuff. We're trying to figure out how to get this into classrooms really cheap, and at the same time be able to expose kids to it without that barrier of entry of a hand license. And I'm licensed, so I totally get the value of having that tool in your toolkit. But there are a lot of kids who aren't going to go through that just to launch a balloon, and we want them working with this stuff beforehand.
The teacher, if the teacher has a license, then.
One person has it, yeah. So that's project, is that all the project-based stuff? It's all the project-based stuff.
Okay, so are there, now that we had like an hour to kind of mull over, got to see some projects, are there any kind of questions, general questions that you guys have before we kind of jump into a little bit more advanced stuff? It's not going to blow your socks off, but it's kind of adding some steps to some things.
What's the image manipulation capabilities of this versus using another external tool?
We're going to go there.
Okay.
Like, if it was me, just because of speed, I'd use Photoshop or InDesign or whatever you want to use. But in terms of like real time, having something react, like an image react to something,
Yeah.
we're actually going to image right now. So image and video manipulation is pretty cool, I think.
Yeah, I mean, it would be for like a photo booth, so it'd have to be some kind of scriptable command line.
Yeah.
I can't think of the other library. I don't know. Magic or.
So it would be actually a combination of like, because you can capture images, so you can hook up a webcam and capture. You know, if I press the A key, it captures the picture.
What I wish I thought about, I have like a program, so we have a friend who's doing colloidal tintypes, and they're actually making a movie out of colloidal tintypes, and I don't know what you know about colloidal tintypes, but like, I mean, this is like 150-year-old technology. Well, I wrote a processing program that gets controlled out of an Arduino, this kind of weird, crazy control box, but it manipulates color values and stuff in there.
Okay.
So you can do this and build custom dashboards.
So up to this point, we've all been. Actually, any more questions? That was a really good one, by the way. I like that. Up to this point, we've been using code and things that we've created with code. Right? We create rectangles with the rectangle function, and we create lines and manipulate the color within code. We haven't gone beyond the boundaries of our processing sketch. At this point, we're going to actually start to pull in some assets from our computer and use them in processing. And an image is the first one that we're going to do. So an actual picture. We're going to pull a photograph or something in, and then I'm going to show you some modifiers, some simple modifiers that we can use with that. So if you guys can grab a new sketch. So I'm going to close some of these actually. Bye-bye, RoboVision. So I'm going to open up a whole new sketch. And again, I'm going to start out with my void setup. And my void draw. Make this bigger so we can all see it. So to use an image, we have to do a couple things. One, we have to go find our image, and we have to bring it into a place where processing can see it. It's not recommended to give the image the file location, or the processing the file location, because once you move that image or you move the sketch from some place to another, you crash, you break the code. So what we want to do is add that image to some place, a folder, where the sketch is going to know where that is, and it's going to move with the sketch as I move it to my thumb drive, or I move it to my laptop, or I move it to my phone, all those fun things. So I'm going to go to Sketch at the top. And at the very bottom, there's an Add File option. So I'm going to click Add File. Now, I can go looking for an image. Let's just do libraries. Is there pictures? Yeah. So I'm going to just snag this desert JPEG. And if I were you, you can go find stuff on the internet, download it, use it. For just right now, just snag something that you have on your computer. So I'm going to use this desert, and I'm going to click Open. And it's not going to do anything visually. Like, that window will just close. But I'm going to show you what we just did in a second here. And so I'm going to go back to Sketch and Show Sketch Folder. So every sketch you create has this folder that it resides in. It has to reside in a folder. Processing gets mad when you just have a processing sketch by itself. And you notice that inside of my sketch folder, I have something called data. So all of the assets that I'm attaching to my sketch gets copied into my data folder. So if I open up this data folder, there's a copy of that desert JPEG. So now this is in a place where my sketch can find it. So we're going to jump into the code side of this. So now we've prepared our image to be used. It's where we can go grab it. And now we need to do all of the heavy lifting in terms of code. So I'm going to create a data type called PIMAG. So it's PImage. Now I'm going to be really creative. I'm just going to call it IMG for image. You know, if I wanted to call it, if I had multiple images, I would call it this one desert, and another one lizard, and another one Jeff.
Don't do it.
I won't. So our setup, we have our normal setup, and we'll do size. I'll do 1200 by 800. Oops, not 8,000, that'd be bad. And now I'm going to do something kind of funky, and I'm going to say IMG equals load image and I have to remember the file name that I want to load, because it's got to be the exact string, case sensitive, file type sensitive, all of that stuff. Here's what I normally do. One, I always save my images. If it's something like my vacation 12/20/2012, I shorten the file name so it's easier to remember and copy and paste. But if it's something like this where it's just desert, I can go find the picture again, and I'll actually copy the entire file name. So I just copied that. So I could right-click, copy. So now it's exactly case sensitive and .jpeg, all the same. Now inside quotes, I paste it. want to make sure everybody's with me because I'm seeing some
So,
furrowed
Terry,
brow.
Go back over the how do you get to the sketch folder?
So again, how do I get to the sketch folder? Sketch, show sketch folder, and it's going to bring this up, and this is my sketch. So this is the code I'm writing now, and then the data folder is where that photograph should be.
Now is the time if you need help to say I need help.
So you need to schedule?
So I went to sketch at the top, show sketch folder, and you should have sketch, blah, and a bunch of numbers, and then data, and then your photograph that you added to your sketch. I want to make sure everybody's to this point because I want to. Okay.
Good. Good. No, that's why we're here.
I didn't have a single photo on my computer. So. Okay, well, I did. I just got
What,
the
too?
photo. So
Okay.
when we were going through the photo, I didn't get one.
Okay.
So where are we going to get that?
So you go to sketch, add file, and now go find your picture you just took, and then open. And since I saw that file name, so I'm going to go to sketch again, and we're going to go show sketch folder, data, and now I would change that file name so that it's something like almost just call it image.jpg. There you go. Yep, inside quotes. So if you're interested in like video game development and processing, you have your drawings of your characters, and this is how you would load all the sprites for your video game characters. So you'd have all of these images, and then you'll see in a second these images act just like a rectangle. So you could treat it just like a rectangle.
Can you treat it like a sprite where you can actually,
Put edges around it.
yeah, or say I want to start it.
So for that, I would probably find some type of game engine library to use with processing, because it would take all of that and do it for you.
So I get a memory warning that I have to switch over.
So, good question about the memory warning. So, processing, its standard memory use is 256. I usually bump mine up to 512. How you do that, because of that question, is again, you go File, Preferences, and right here where it says Increase Maximum Available Memory, put 512. Nope, because it usually says it requires restart. So now we want to draw that image. So we've, again, created the advanced data type. We've loaded the image into that. So we've created the bowl. We created the image that we put inside the bowl. And now I want to go and share that bowl of soup with Jeff. So I'm going to type image. For the sake of practicing, I'm going to find image in reference. And again, this shows me that I create an advanced data type called pImage, image. And I've loaded IMG with LA defense. And in void draw, the image function has the image I want to display and its origin. And I know that because down the bottom we can look at, yes?
Is that a key sequence that you highlight a string and then you hit it and all of a sudden
Sorry?
you highlight an image and all of a sudden the reference page.
So I right-clicked, and then find and reference. So for Apple users, it'd be Control-click. So I'm going to type IMG, and I'm going to put it in the upper left-hand corner, so I'm going to put 0, 0, and I'm going to hit play. And if I did this correctly, I get my image in my processing sketch. I want to make sure everybody gets to this point before we start messing around with our image. Yep.
Eric, can you go back to the code, please? So you can put in the draw the image, in the parentheses, IMG, and then origin.
So the question about, like, you cropped it. What we can do, if you want to shrink that image, you can give it a width and height by adding 2 more numbers to what we have here. So I can put, so the 0, 0, I can put, 100 by 100, and it's going to shrink my image down for me. Yeah, it'll distort it. So I'm going to add. It's a feature. So I just made my image smaller.
Does your canvas have to be in the same aspect ratio as your code?
Nope. Excuse me.
Yeah, but if you're just saying it as
Yeah, like this is what I get.
Oh, you didn't put it in the size.
But that change takes place.
Okay, so everybody got an image to play with.
yeah.
Now time to mess that image up. So we can, there's a couple different things. We can apply a tint to that image. So here we go. So tint is a modifier that goes above it. Because we're applying it to the image. We're not, as you'll see in a second, like we can apply a filter, but that goes over the top of the image. If that makes sense. So I can do tint. And I apply an RGB value tint to this photo. And I'm going to apply sure. So nighttime. Sun rises. Of course, the sky gets a little green, a little too green, but
How are you setting the density? Is that,
sorry?
how do you set the density? How does it know how much to tint? Because if it was 100% red, you wouldn't see the image.
So
it's
transparent.
So automatically in the tint function, when you call tint, that full value of tint is translucent. It's transparent. Sorry, it's transparent. It allows light to pass, a certain amount of light to pass through.
So there's no density. It's just adding those color values onto the underlying pixel.
I think it's subtracting, actually. I think it's subtracting the other 2 color values. Is that right, Derek?
Yes.
Subtractive? I think this is subtractive.
And while we're here, because to make it like time sensitive, there's a bunch of built-in time variables you can use. So like up here I have second, which is not how many seconds since the sketch started, but it's the second hand of my clock on my computer. So I can't see it right now, but like 122 in X number of seconds. So that's what second is. I can do hour. So if I wanted to have an image that kind of basically reacted like a clock, like sun up, sun down, nighttime, all that fun stuff, you can actually set up a tint cycle that shows an image, and it'd be dark, and then gradually increase or decrease a tint color so that that would show kind of the time of day. You could do day, you can do weeks, I believe. No, it's just day, month, year is a variable. So one of the dashboard we didn't show you, but the balloon, advanced balloon dashboard actually has the time stamped with the day, month, year, and hours, minutes, seconds. So we can actually use these to our advantage. So that's tint. What I think is really fun is applying a filter. So I'm going to type, and this is after the image. So I'm going to apply a grayscale filter. So taking a color image, I'm going to make it a black and white image, semicolon, and now I have a black and white image that I can play with. So here's the different filters that you can apply. So there's threshold, which gives basically 2 values, and you can set that threshold of what contrast ratio you want.
Threshold is a range of values between 0 and 1. So know that when you pass that something that it's a range of values between 0 and 1.
Gray, which we already did. Invert gives you kind of that fill negative look. Posterize, which you pass it, I think, a number between 1 and 10. Well, it's the number of colors that you want to break it down into. So this image on the left has, it might have 100 different colors in it, but the image on the right only has 4. So it takes that and combines them into only 4 colors. Blur, and how blurry you want to get increases the number.
I never used blur.
All-nighter vision.
I can see it.
Erode, and the last one is dilate. So a lot of these filters that we add to things, a lot of times I'll add a filter on top of a filter just for fun. So we can add, whoa there. I'll add a blur filter on top of this one. Queasy view, or I lost my glasses view.
Derek, have you ever tried to use blur as a variable?
This is going to be really tough.
If you go back, does it reload? It doesn't. This is the problem with these filters. I ran into this when I was working on photo stuff before, is that these filters don't save the load of the image. So what you perform to this only moves in one direction. As you alter this through this sketch, the timeline only goes one way. Know that. And I think there may be some tricks for reloading the image.
I don't use filter too, like I don't use filter too much, and so I can't speak to that.
This was, remember when I was building
Yes.
the box? We were,
Thorn in my side.
yeah. Here's an interesting thing, is that, I don't know if this would work or not. Can we reload the image by connecting it to a key press? Do you know what I mean?
Yeah, but then the draw takes over again.
You could put a time constraint on it using millis.
So same thing.
This is covering it up so fast you can't even tell.
Bummer. Well. So there's an image. I can treat it just like a rectangle. So I can say mouse X, mouse Y. And if I had the background here, then the image stays the same. Here's one way to use the image. So background, you can actually add an image as a background. So the background function, I can type img. Here's the caveat to this, is that your sketch has to be exactly the same size as the image you're using. So if you're doing game development and you want a background and you want that to be your background, you have to make sure that that image has been edited so that it fits the background of the window that you're using. Because if I try it right now, it's going to get mad at me and say background image must be the same size as your application.
Is there a function, I assume, to measure an image or report back?
You can open it in most photo editors.
No, I understand, yeah, I'm saying in the software, is there a call that you can call the image and report back X and Y information? You think that'd be pretty basic?
Not that I...
And if it's gonna complain, you know, decide to go with the size of the image, and it could. So you put that up top in your setup.
Yeah.
And then draw your window to the size of the image that you're gonna use. Using that.
Oh. So, but I can use these as variables. So image img, since I'm creating an object essentially of this image, I can't use it here, obviously. It just told me I can't. But I can use image.height, image.width as a variable. So just like I use height and width of the window, I can apply the same thing to that one image. So if you remember back to when I had the computer vision thing up and there was those lines, those are bounded onto that video by video.width and video.height. So if I wanted something that stayed with it and
Does the error because you can't use to find that?
and it might be if I had it and then moved size down below this, it might work. Yes, I know, go away.
This is great. Did you take that picture?
Yeah.
He once rolled a processing sketch in front of me with this cancel halves photo in it, and I was like, just irritate that. Do you remember that?
Yes. So that's image. Are there any questions on image? 1, thing that I want to double check so that I don't, because sometimes I forget things. So background, that's about it. Alpha, it allows you to check the alpha. So alpha is its transparency. And let me see here. So an image, I'm going to draw a rectangle here really quickly so we can talk about alpha. Since we're kind of doing some imaging stuff. So I'm going to move this rectangle so that it would end up on top of the image. And sorry about that. So I'm going to do 255, so a red rectangle. I'm going to add a fourth value to my fill. And this is the alpha or transparency of that rectangle. And I'm going to put mouse X. Hey. Yes.
By the way, just if you do put that image width, image height, if you put the size function after you go to the image, your window automatically.
It does? Cool. So it does work. So as you can see, this is 0, so that this mouse X equals 0. Let me see here. I'm just going to have the image be 0, 0, so it doesn't move. And down here, it's completely opaque, meaning that value is at 255. And as I move up, it gets more transparent. So it's not disappearing, it's just becoming clear. And as I move, it becomes opaque. So you can do some kind of cool, you can hide things, or you can add kind of your custom color filter to images depending on what you want to do. So I can take this, instead of a mouse, I can do 150. And now that I can still see through it. If I want to get rid of those black lines around my rectangle, I can do no stroke. And now it's just a red rectangle with no line around it. Last thing we're going to pull in is a font. So if you remembered, if I do text and I say, wow, this is cool. So I'm doing width and height divided by 2, putting it in the middle of the screen. We'll hit play. So it's right here, you can't see it very well. So I'm going to give it a fill color of black. And you get this kind of computer font, right? It's just kind of a nondescript font. Let's say you want a different font. We're going to go up to Tools. So instead of Sketch, where we imported an image, we're actually going to create a font for us to use. So we're going to go Create Font. And now I can find all of these fonts that I have actually residing on my computer. So somewhere in your computer is this folder of all of these fonts. So if you're a graphic design person and you have like 100 fonts on top of the fonts that you already have had on your computer, it'll actually show up on here. So I can go find a font that I want, find something that's kind of different. Sure. And I can set the font size. 48 is fine by me. And then I can name it. And I'm just going to name this my font. VLW. So the VLW is the font file format that it's going to use. And I'm going to hit OK. Again, the window just disappears. Where'd that font go? If you want to know, we can go show sketch folder. And in my data folder, I have that font that I can use. So this data folder is a place that's like the collection place or the desktop that I'm going to use to collect all of the stuff I'm going to use in my sketch. Anybody want to take a stab at what the data type for font is going to be called? It's not very creative. And I'm just going to call it font, not font, font. Just like an image, I'm going to say font equals load font. And in quotes, I'm going to say my font dot, what was the file extension? Oops. LW. If I want to apply this font to a text piece of text, again, it's a modifier, so it's going above that text. I'm going to say text font. And I'm going to say font. If I wanted to change, you remember how we have that font size function? This load font, or the text font, can double as that size change if I add a number after the font name. So if I go back to my processing sketch, if I want to change the font size, I can add 20 after the font, and now it's going to change the size of that font. If I remove this number, it's going to be that original font size and nice and crisp and clean. So remember when we created that font and we said it was size 48 font? At that size is going to be its optimal cleanliness in terms of lines. When you start changing this font size after you've created that font, it gets a little blurry, just like you saw before. So if you want something nice and crisp and clean and big, you need to go back and change either change your font file size or make a new one so that you have multiple fonts, and change that size at the beginning rather than kind of go around and change the text size if it's getting really big. Most people can't tell, but like when I put this as 100, it gets kind of Not so good. The edges are a little blurry. Any questions on font?
Is there a way I could say, for this font at this size, only pixel long, but this string?
So the text modifiers, so we go down, we have all the load font, all that fun stuff, and we have, where's text align? So now I can say, so this one is center bottom, center center, center top. So you can align these things to how they would be in that imaginary rectangle around it. You can also do the line left and right.
I was just thinking, I want to put string of text in a box. So I can either resize the box or I can resize the string. And it's going to change, right? Because on the font that I've got.
So if you add 2 more numbers to text, it gives you that the dimensions of that text box. Here, let me bump it up. I'm sorry. So this is the string. This is where that text is, that origin, and then this is the dimensions, the width and height of that text box. So let's say that this is 1,000, 100. Now that's going to be fine, but as it'll be interesting to this. So as I shrink that text box down, it's starting to bump. It bumps it down. So you can constrict that text to a certain area.
I've never assigned variables to text before. That's pretty cool.
So text can also print out variables. So I don't have anything set up necessarily that's going to be moving around, but I can say mouse X, hit play. Should be able to. I mean,
Yeah, it's the same.
so now as I move around, these numbers change. So just how Jeff was doing, showing the pressure and temperature, it's basically a series of text string lines that are printing out whatever variable he's getting over serial.
So you get some cool dashboards, like say take an image of the front screen of an old analog oscilloscope,
Mhm.
and then right on the screen pull out your data in real time that's coming in from your sensors. You know, it's just better than drawing a couple of rectangles.
By the time you guys get here where you're importing data, like right now, Derek's just importing from the mouse. But it becomes really creative. Our ability to manipulate and create with technology now is just wide open.
Let me see, because we had a coworker last.
Are you looking for Chris's
Tom.
visualization on the distribution of isotopes?
No.
Oh, all right.
Let's see here.
My dashboards tend to be a little dry, because usually it's the night before some presentation. Just
So that's what I'm thinking, if you don't want to have to sit there and illustrate and draw this really fancy dashboard, just take a photograph and use that as your backdrop.
So this is one of our coworkers. I got a comment out. Just go away. So you might recognize this from a TV show. So this was a coworker of ours, Tom Flock, he created this dashboard that we have a spectrum shield that shows, basically breaks audio signal into 7 different bands of frequency. And then he showed this, so he had bars, a bar graph. So he took the image and I think he created this image, or at least modified something he found on the internet with the SparkFun spectrum shield image and stuff. And he made bars that actually moved up and down. So you can highly stylize some of these control panels, or you can leave them as just, you know, rectangles. It's sad to say, but a lot of times our projects kind of don't really get beyond proof of concept because they just work. And there's, you know, there's some of us that want something a little more highly stylized and just be like, okay, now I can, that have kind of a finish to them, and then some of them just work. Depends on what you want to use them for and things like that. Especially since, oh, go ahead.
If you're creating stuff, send it to us, because we love to see what people
Yep.
do.
Can you grab data from the web page or endpoint?
Oh, yeah.
So, this is getting,
Yeah. This is where the hole goes really deep.
so you can pull data off an XML or a RSS feed. And it's actually one thing I'm playing with right now is, you know, the government actually opens up a lot of data to us. It's a lot of data that we don't think is that sensitive, but things like river levels and water gauge levels and all of this kind of massive amount of data that's just sitting there as an XML file. You can actually go pull that off the web or have processing pull it off the web and then visualize that data.
That's cool, because in the spring, I looked at all the Snow stations in the areas where I wanted to go backpacking to see if it's melted back yet. Wouldn't that be cool to have the map with some sort of graphic of how deep the snow is?
You can build a scrubber that, like, you can build a scrubber in processing that when you open that applet, goes in and pulls everything and gives you a daily update on what's going on.
Or, you know, your favorite destinations, you know, you have dots on a map, right? And there's red meaning still snowed in, green means good to go. And those colors, depending on that snow level, will change color for you.
So what I do now is I do it on Google Map. I click on those dots, because you set that up and it opens that web page because I've hyperlinked to it, right? But this would take it one step farther. I don't have to open it. I can display the current conditions.
Yeah, there's a bunch of Google plugins that work with processing.
Very cool.
Because it also, it accepts all the major formats. It accepts JSON and CSV and XML, and it, it's good glue. Really good glue. Like, this is the glue thing right
This is
here.
opening the door right here for all the things I always wanted to do. I had no idea how to access it.
Yeah.
This is the starting point.
And you can save data to a table or a text file and then use it later.
So the balloon, what I didn't show is the balloon stuff all writes to a text file. And then we can take that text file and feed it to OpenOffice or Excel or whatever and graph from there. It also, you can take those coordinates, write them to Google Maps and do a plotted trajectory on Google Maps.
So, like, crazy, you know, we're starting to talk about applications, but every day I come in here and I'm like, we talk about some type of problem, and I'm like, give me a second.
Yeah.
Like, and usually, I would say 90% of the time processing, doing something in processing can solve our problem.
So, and there's been a lot of talk about Arduino, and one of the things that I didn't show is I've got a project that writes data from a sensor array to Xively, to this open data channel. And so there's a library written for processing called EEML, which is Extensible Environmental Markup Language. And basically, it's XML for sensor arrays. So you can get live data to the web and take data from the web, and that's a cue for you about the global awareness plan.
So I built It was before I started here, about a couple of months before I started here. I was teaching in Portland. I was teaching workshops at Hackerspace, and pretty much anybody that would allow me to teach. And one of the projects that I developed for the Hackerspace was the Global Awareness Lamp. And what that was a processing sketch and an Arduino with a red, green, blue RGB LEDs in it, and a lamp. And I'm going to go grab the actual lamp right now. That the processing sketch, when pulled these data points, one was temperature in eastern China, humidity somewhere in India, and the solar radiation level in Hillsboro, Oregon. Oregon was where I lived. And then map those to 0 to 255 so that I can get an RGB value. And then ship that to the lamp. Then the color of my lamp changed depending on how those variables changed. So as the sun went down in Oregon, that value would start dropping. So the red would start dropping out of the lamp color. As the humidity changed, so that color of my lamp. And so you had this lamp that was reacting to these different variables all around the globe. And you could have changed that to your ground temperature in your garden if you wanted to, or Jeff's temperature in his basement, if that was a live feed. Xively has now changed. It's kind of closed off a little bit more than what it used to be. It used to be where you could go and search for any data point, and now you kind of have to know the person. You have to be able to share the ID number back and forth. So it's a little bit more, if me and Jeff know each other's feed ID numbers, we're good to go. But I can't just go find some dude in Uzbekistan anymore.
It used to be 250,000 channels of data that you could pull. And it was radiation, and it was temperature values, and it was wind speed, and it was how many fish I sold at the market today. And it was just all this uncatalogued data that was live all the time. You had live access to data. And like Derek said, when they sold, we bought the company about probably a year and a half ago. And Derek and I had done a lot of work around the previous incarnation of it, which is called Cosm. But when it changed the way that we were able to access data, which is sad. And we're trying to figure out whether we have the bandwidth to develop another completely open data channel or not, and let people have each other's information unfiltered.
So this is the Global Awareness Lamp. Just basically wood and run it through a table saw. And then laser cut lens. I'm not going to pull that out. And here's the Arduino with just a bunch of red, green, blue LEDs. And then this I pulled it recently, not recently, but because I needed it for another project, but it was Bluetooth. And so this actually was just plugged in across the room. And if I had that processing sketch open and I set it as a on boot up load or open, so whenever my computer booted up, it just automatically was feeding data to this lamp via Bluetooth, and so it was just changing color. And since these data points change just slowly over time, this lamp, you'd be sitting there and it wouldn't change color right away, and then you'd go eat lunch and come back and it'd be a different color. So it wasn't this kind of like strobe, crazy color lamp, but it just changed over time. I never get this back on, right?
So, this is what Xively looks like, and my data's not live right now, so nothing's going on. But you can see, this is something I did for a workshop in Vermont about 6 months ago, where we were doing network data for rural applications. And we were taking this just wirelessly from a Bluetooth feed and pumping live data out on 3 sensors. And you can just push your data to the web. What people do with it is up to them, how it gets translated. but you know, there's two ways of looking at this. One is that, you know, I can shove my data to the web and somebody can use it, or I can get somebody else's from the web and use it. Now, like, the layers of interactivity change significantly.
I mean, and the update is so quick that if Jeff hooked up a button in an Arduino and it just was a 1 or a 0, whether you push the button or not, that can be controlling something across the country that's just looking for a 1 or a 0 on its feed. So, like some remote control stuff is pretty powerful without having to have this giant infrastructure to take care of it.
So this is something we're working on for the United States Science and Engineering Festival, and I just wanted to see if we could get a channel up on this out of a wireless connection. So the idea is that we can put up a channel at the United States Science and Engineering Festival for our soldering booth. So we've got, like, when we go to these big events, we have 700 people who show up to learn how to solder. And they don't want to stand in line. You've only got a certain amount of time. So we give you a number. And then we put up a now serving number on the web that you can check with your phone. So you have an idea of when you're going to get, you know, your spot at the soldering booth. And you don't have to walk anywhere. You can check this from any mobile phone. So it's a way for us to deal with really chaotic stuff. But that's I gotta finish that. I forgot all about it. Thank God. All right. Do you wanna Park? Bezier?
You can, how about you do curves?
All right. I'm trying to figure out how to pick up.
So if you haven't noticed yet, we've kind of been avoiding things that are curved. There's a couple different curve and line that are straight functions in processing that we play with. So there's arc, which is so if you think of a circle, arc just defines a section of that circle. So you create an ellipse, basically, and then you tell it a starting point and an ending point, and that's that arc. But there's also a couple different, can you go to reference for arc? Because it shows a really good image of this. So here you see it creates an ellipse, and this is a series of arcs. And you define its starting point and ending point with pi, where it is on that arc. So like pi or half pi or quarter pi. And so scroll down, I can't remember off the top of my head which numbers are which.
So X and Y are the first two coordinates.
So that's the center of the ellipse. And then you have C and D, which is the width and height of that ellipse. And then you have a starting point and ending point.
So I'm going to start a new sketch there.
Sounds good. And you could probably see now why we didn't introduce curves and arcs and stuff like that at the beginning of the day, because your brains would have been mushy.
So I'm going to give this, I'm going to center this on my sketch and call this 600 and 400. I'm going to give this a width. I'm going to give it a height. I'm going to give it a sweep. Sweep?
It's width, height, start, stop.
Start, stop.
So do 0, and then pi. Should be a half circle.
There we go. So I'm going to start changing this. I'm going to call this is my origin right here, and I'm going to call this mouse X, mouse Y, use the corollary function to this below. Call this Bezier.
So you have 8 points, 8 numbers that you can pass to a Bezier curve.
So I'm going to grab this whole thing right here just to translate this concept. I'm going to comment this out so we're not looking at 2 things at once. And this is going to be one end of it. This is going to be a center of pull. We should probably do this as a picture. So I have a start point, and I have a stop point for this curve. Now, if this line right here, if this is 100 down right here and 100 out, notice I use these a lot because it's easy to do this. So, and we'll call this point 400, 100. If I have a straight line that goes across here, if I divide this into quarters, I now have points where I can pull this curve from. And I do the math on this, and I start to generate complex curves, or curves that do things in multiple dimensions. What did I do with that? So I've got 0 and pi, and mouse X and mouse Y. I'm going to give this is starting in the center. I'm going to divide this by quarters. So 600 would be half. I'll go to 300 here. 300, 400. And I want an end point of 900. 400. So you can see that I'm really working this part of the circle, but I'm not getting much out of this part of the circle, and that's because that's a hard-coded definition at 0 pi. So what I'll go back in and do is I'll give this inverse right here. So now we can see the relationship between these two things. When I'm level right here, I have a curve that responds to my up and down. When I get above that line, I get an S curve and a sine curve. Now this is cool because it gives us this ability to do some depiction in sine waves. And when I'm flat, I get that nice standardized curve.
Add a no fill modifier to above your curve. Capital level. Yep.
Sorry, I started speaking real English.
So you get this kind of wire framework. You know, you can start imagining too with, you know, if we look at a stroke with 3 random values, you start getting some kind of crazy lines going on.
Go in here and I'm going to give this random constrained by do these. Is constrained by 0 and 400, right? No. Is constrained by, it's the second point in the curve, so I want this constrained by halfway between 600 and 1200 is 900.
Ooh, I get where you're going with
Yeah,
this.
you see
Okay.
what I'm doing? Yeah.
1200.
Yeah, and 1200.
And then change the mouse X. Mouse Y too.
Yeah. And I'm going to call this constrained by 0 and 800.
Give it the same, 900, 1200, and that was 900, 1200, and then do, and then change X, the mouse X and Y to random 300 to 600. Right? Am I right? Yeah.
This is going to happen really fast.
This is gonna be cool. So add a random stroke color to it. No, leave the no fill.
Oh, right, yeah, got it. change some of these numbers.
Yeah.
Because we're only getting stuff below the line. So this is my first point out here. We're constrained between 300 and 600 going this way. That's cool, I like this, but this I want constrained by the full screen, so I'm going to say 0 and 800. And the same thing in the second one, because I want to use the whole screen. This uses the whole line, or it uses the second quarter of the line.
So you want 0 to 1200 on the next one?
This one I want
0 to 800, right?
Yeah, this one wants to be 0 to 800. We've never done this before. So that's using the whole width of that line.
It's creating like this apple on its side look.
Let's use the whole screen. So this is my endpoint. I'm going to change my endpoint to 0. That's my x coordinate. I want this in the middle of the screen, 400. Now my other one over here, I want to go full length of the screen, so I'm going to go 1200, and I'm 400 in the middle of the screen. There we go. That's what it's meant for. I'll play with this some more.
So my wife thinks my job is making really cool screensavers. Hopefully she wasn't watching at this moment.
Right. Random?
Random 1 to 10. Yeah.
Better. I can watch this for a while.
Do you have any control over the access?
Oh boy.
TV, take it. Take it. We love questions because we don't know. I think.
Do we want to go 3D?
Well, because you could, I mean, if you look at that, if you're to consider.
Oh, with a curve.
Right, like if you were to, yeah, if you were to, I mean, I know it has 3D capability, but.
Oh, yeah. Yeah, it does. See, you have z-values. So
I don't know what it is.
I'll let your brain take care of that one.
My brain will not be able to do that, but I know it's super simple. Turn it.
That must be how they do the dresses though. They must have
Yeah. Oh, yeah. We can do 3D stuff. In fact, one of your handouts is just kind of getting a cube and kind of learning to deal with 3D. Takes a little bit of different setup code, things like that. I'll let you kind of play around with that. I think during free swim time, if you want to kind of jump into 3D, you can play around with that. You can play around with they have the basic geometry of a sphere and pyramid and cube, all that fun stuff. But, so you'd be able to take this, add Z dimensions to it, and then put it at like a 45 perspective view, and I think you'd get some crazy, I can't even.
Translate?
You can translate in 3 dimensions, I believe. Okay, here we go.
this is what this becomes. Like this, by the time we get here, we start asking questions we've never, you know, somebody asks a question we haven't tried. So we go, well, what about? You know, I love this. This is one of the reasons I love this software, because I feel like even after years of digging around in the software, somebody asks a simple question and I go, wow, let's check it out and find out.
Okay, so let's go 0, 400.
Where did you, how did you do that?
I was in reference and I copied and pasted the code.
That's a teacher thing right there.
So, what was this? What was this originally? This
That
was
was
a Z.
Z1. This is Z.
Oh man, this is gonna make my brain explode.
I don't know if you want it to be. We don't want the Z to be red.
Oh wait, let's do it for here. This is the Z origin. Let's do 0. What was this again? Oh, lost. I need a reference. Here we go. So that's x2, y2. This has to be between 0 because my screen is actually 0 for the Z and it moves out away from me. I don't know. This is awesome. Right. Work our way in this way. Y, you have 400, X. Excuse me, I'm gonna look up three-dimensional. Forward, backward translation. I want. Rotate X and rotate Y. Oh. Here's my reference. That one. Busy vertex with XYZ coordinates can only be used with, oh, I have to put it in keep reading.
crunching.
Love it. Frame buffer object, not supported by this hardware. I just maxed out the graphics card. Let's try this. Frame rate.
Crunch.
Would decreasing the frame rate help?
Maybe, we'll see.
Just increasing?
This is 30.
Wow.
Really?
Go to 5.
Huh?
Go to 5 and see if it'll render. No, it's just it's locked down.
Got it to render at 1 frame a second. Still pretty
You got it to render?
at 1 frame a second.
Wow.
That's still so slow.
No, mine still crashed.
I didn't use my hard code on that.
I love it. I love it that we were able to overcome the processing power of these machines.
Hooray!
We crashed computers!
Let's try this. While we're in 3D mode anyways, we're gonna do box, and we're gonna do 100. And I already have the rotate stuff good to go. And I'm going to translate it. And I'm going to go over this, or translate.
It's getting late.
600, comma, 400. Because so when you do 3D shapes, you don't, at least the simple geometries like a box, it doesn't, you don't give it an origin point. What you do is you create a box and it's always at the 0, 0, and then you have to translate them using that kind of that matrix style that we learned earlier. So this is a 100 pixel box, meaning it's a cube that's 100 pixels by 100 pixels by 100 pixels. And I rotated it pi. I might have to, on its x-axis, and pi on its y-axis, I might have to do half pi. And that still doesn't work. So he's got the 3D crazies over there.
Wow.
So my graphics card driver might not be updated or something like that. The drivers for it. So
That's pretty cool.
yeah, it's like a computer hairball. Let's just hope it doesn't cough up.
It'd be fun to slow it down and watch exactly, like, to see each individual curve. So if you push your frame rate down to maybe 4 times a second or 3 times a second, you'll see the growth of it.
What do you want to do with your hardware out? we're actually gonna snack some hardware for you guys. So beyond just to play around with in classroom. So we're gonna cover some really basic serial communication. So we're gonna grab some Arduinos and some sensors and USB cables, and we're gonna code up an Arduino to be sending. I think we'll just do one number to start with. I think that's an easy one to do, and then we will look at how we can use that number. So just like we've been setting variables, int x equals blah blah blah, or int y,
We can do the same thing with a number that's coming in through our serial port or over our USB cable. Yes, it's already wired. They're gonna have to install Arduino.
Who doesn't have Arduino?
Everybody got it on their computer?
We can either give you a computer that has it on it, or you're welcome to download it, or you're welcome to just watch. Okay.
So, we ready to download it?
Arduino.cc. Do you want?
Sure.
Okay, all right. I'm going to collect these when we're done, but we're going to give you some loaners. These are Arduino Pro Minis that are pre-wired with a light sensor and some other stuff. So we can go right into hardware with these.
Ancient.
And which Arduino software?
I would get 1.5.1, is that right?
1.0.5?
1.0.5, do not get 1.55, it's really not.
Don't show it.
Okay. Oh, if you got cords, then I won't even have, because you got cords for the makey-makey. It should work, it should be the same, so.
They're gonna need drivers.
The Mac users are, the Windows users should be able to get them on Arduino. Oh, you got a cable, you got cables, okay, same cable will work. If you're a Windows user and you haven't used Arduino before, or I'm sorry, if you're a Mac user and you have not used Arduino before, then I'm going to have you go to ftdiship.com, it's all lowercase, ftdiship.com. You're going to go to drivers. You're going to go to DCP. From DCP, you'll grab the packet that is not the PPC packet, but can you do me a favor here? Can you pull? So Derek's going to drivers, and he's going to grab DCP drivers, and when we scroll down for Max OS X, we're going to go 64-bit 22.18, not the PPC version. So you'll pull that down. When you pull that down into your downloads, it should be a fairly quick download, you'll double click on that DMG and the download file, and it should automatically unpack from there. You'll get to a box that says 10.4.4, I think.
There's 10.3, 10.4, 10.5.
Let's see here. So you're gonna grab this one there. Okay, cool, good. The one on the right hand side, yep. So not the one, what does it say, 10?
4 or 5.
It's just the one on the right hand side in the file. When you double click that, it should take you through the installation scripts.
Do you have any experience with Windows 8?
If you plug in, it should run automatically.
It may tell you it's from an unrecognized developer. If you do that, right click, hit open with installer, and just hit OK.
Did you get that?
Not for Windows 8.
Okay. So what I'm going to have you do is open your device manager.
Yeah, so I'm looking right here at the
Right click.
and I tried to update drivers. Went to browse my computer, went to where I just downloaded.
No, go to our go to your Arduino file.
Yeah, that's where I am.
Just go to the drivers
Right.
file. Hit OK. Yes.
I drove down to the truck. Thank you.
Is anybody else with Windows having problems? Is there anybody who needs help? Wow, this is the fastest this has ever happened. Usually this is the point where I'm crying.
This has the most ancient version of Arduino.
I've never seen Windows 8 before today. I borrowed my wife's computer and it's kind of blowing my mind.
It's actually not as hateful as I thought it was initially.
Once you get past that star screen, then it looks familiar. Right?
Yeah. This didn't have the FTDI drivers installed on it?
It's not updated.
My printer, which is Arduino based.
Let's just swap computers.
Do you want? What do you want? Do you want me to? Do you want to run my Windows or do you want to run my Mac? Second one down, set up, execute.
Yeah, he did.
Oh, that's all right.
Thank you for doing this on the fly. is Uno, right?
I think if not, no, many.
Let's do this one.
I got the link to work with it.
Did you? Thanks. Appreciate it. Like, have you done this before? Have you done this with us before?
Because I haven't done it.
Do you want me to?
No, I got it. I'm fine. I was just joking. Okay, so everybody, someone at this point,
Close to.
close to.
The other way to do this is to open up file, examples, basics, bare minimum, and you'll get exactly what Derek's typing right now.
Does this look familiar, by the way? Instead of draw. Okay, and I know we have, not all of us have gone through an intro to Arduino class, so it's going to be kind of a type as we go, yay. In our void setup, we're going to run serial.begin, and it's a capital S. And inside there, we're going to put 9600. And 9600 is the baud rate, or the speed at which this little computer is going to talk to our big computer, my laptop. So it's how the agreed upon speed at which the Arduino and processing are going to talk to each other. So in my loop, I'm going to create a variable. It's going to be an integer, and I'm going to call it light. And it's going to be equal to a function called analog read. And it's going to be A0. So if we look at our board, this board, hopefully yours isn't blinking bright like mine is and annoying. The light sensor, you can find it, it'll have A0 next to it. So that's how we know what pin it is. And what we're going to do is we're going to serial.print line, or print ln, light. A0. I know you went from one computer that had zeros in the middle of, or a dot in the middle of the zero, to another one.
Yeah, I've got a full project on mine. It's got some really ugly stuff in the Arduino, so I can't do the Arduino on my laptop.
So, again, this is just creating a variable, and then we're storing a value that we're going to getting that's between 0 and 1023. That's what we're getting from our light sensor on our board. And then we're printing it over the serial port. And we're going to upload this code.
So I want to make sure that everybody has selected tools.
Yes.
That we've done board and serial port, that everybody's got serial port. If you're on a Mac, you've got something that says dev/USB TTY. That's what you're looking for on Mac. So we want to make sure that that's selected, that this code is headed in the right direction. Sorry, I didn't mean to jump shit.
That's fine.
So when I do this, what I'm going to do is I'm going to take this code, I'm going to compile it, turn it into ones and zeros, and shove it to the chip that's on here. The way I know that's happening is right here where I plugged in. If I hold this up and look at it on the right-hand side, there's a silk screen that says RX and TX. When code's going back and forth, those lights are lighting up. We know the mail's going, right? The mail's coming in and going out. So when I hit the play button or the right arrow and I push that in there, I should be able to see that RX and TX light fire up, and there they go. So now I should have something, doing something, uploading, there we go. Oh, Derek, this one didn't go on Uno. I think this is Pro Mini.
Okay, it depends on what bootloader we have.
So if it didn't work on Uno, select Pro Mini at 5 volts, 16 megahertz with Atmega 328 and give that a try. Some of these boards that are in our fleet have a different bootloader on them. That looks much better.
Which Pro Mini did you say?
I selected Pro Mini,
Check mark just checks the code if it's correct.
5 volts, 16 megahertz.
There you go.
I still didn't get it. Still
Check the serial code.
There's only one showing up. It's blanking, it's enumerating.
Look at the program. Check my program.
There's one built into our agreement. Just click on that box, and there's Windows where you move those serial numbers.
As soon as it finishes, it's called again.
Yep. Yep.
No, there it goes. Okay, thanks, Mike. I don't know, for some reason that one wasn't cooperating. Okay, so I just opened my serial monitor, and that's in the upper right-hand corner. Is everybody got code loading? No, no code loading. Okay. Yeah.
I just hit the arrow instead of. So now you
No,
see
go to the
it's
328.
a massive amount of number. It was really fast for us, but the computer can see it pretty easily. How do you what? So if you want to slow this down so you can see it, so there's just not a blur of numbers going by. Put a delay in here, and it's in milliseconds. So you could put like 100 millisecond delay. Then I'm gonna upload it again.
And now when I go back to my serial monitor, It's much slower now. I can see. So everybody got numbers on a serial monitor? Next step, processing side. So I'm going to close this, and I'm going to go open up processing. And just for the sake of getting this thing up and running, we're going to go to examples. And actually, you know what? And you'll find under the libraries folder, so mine's really expanded, but you'll find a libraries folder. Click on it, and then you'll find serial. I wonder what their simple read is. So if value is more part read, val, fill 0. Interesting. So let's just try this. Tell you what, I'm going to get a different example here. So just bear with me, because I was just looking at processing and see what they had. We're actually going to go to, so you should still have Arduino open. Everybody got Arduino open still? We're going to go to examples in Arduino. And the communication examples in Arduino, they have, so if we go to, we want to find communication graph. Okay, so you're going to open something that looks like that. And it'll pull up this graph example. And we don't want the Arduino part, but if you look down, there's the processing code, and it's all commented out. It should be all gray. We want to be able to cut that and paste it into processing. So, which gets somewhat tricky on a smaller window, because as you can see, so I'm actually going to put my cursor there, go down to where I want to get, which is right here.
So if you Google, go ahead and close your serial window. Google Arduino graph.
So from import processing all the way down to, you'll see there's some max MSP and then a bunch of random letters and stuff. No, so you want it right above it. So there's a star / that's kind of the end of the processing stuff. So we're going to copy that, and I'm going to put it into processing. New sketch. So I'm going to go File, New. So what this is a graph sketch. It's hard to see because of the projector. I'll move it over. So this is graphing the value of my light sensor. So if you guys get some type of error that's like in this right here, So change this 0 to like a 1. Yep. So part of this, and it's really hard to show, so at the very bottom, see the black window at the bottom? There's should be a bunch of text that says like RX and TX version, blah, blah, blah. When you hit play, there will be a number inside of brackets with your COM number next to it. So you want to find the COM number your Arduino's on and use that number inside the brackets right here. Tools, so go to, yeah, so go to tools.
Oh, okay.
Tools, fix the serial library. Yeah, okay. Oops, so you should be 1, yeah. Oop, something got clicked funny somewhere. So at the very, no, the very, there you go. So there's your, no, it's an example that's in Arduino. So if you want to use this in a classroom, you just have them write. In fact, they can just upload the example sketch, the Arduino side, and then you just copy and paste the other side into processing, just like we did. Inside serial. Try.
I wasn't sure where to put it.
So we can try number 4. So put number 4 in there. There you go. So when you run a sketch, it'll show you all your different COM ports or communication ports. Mac, because you have built-in Bluetooth, you'll have, Bluetooth, yada, yada, yada. You want this USB serial one. Yeah. Can you scroll it to the left further? Like try to go all the way to the left, see if there is a number there, it just hasn't. Uh-oh, hard code it. Some of you, yeah. So some of you Mac users, depending on version of your processing, it'll ask you to like fix the go up to tools and say fix serial library. So if you go up to tools.
So which app should I?
So be in processing. So click on it, go to tools. And then fix the serial library. And then just hit OK. And then you type in your password. Yep, try it again. And you want number 4. So if you processing serial. It's in your setup code. Scroll up. So you have serial list. Where it should have been gone right. You might have accidentally, because when it highlights it, you might have just hit a letter key or something. Oh, there you go. So number 4. Now hit play. There you go. Graphing.
It's very big numbers. So what is the Y scale on this plot?
So you might want to change that.
Should I reboot this?
No, it might be something that.
These numbers are very suspect.
Wow.
Wouldn't you say? It's like the print line's not putting in a character turn on line.
Yeah, you're getting in a weird. Yeah.
Do I have to reload it?
Nope. Should be on there.
Do I have to restart it?
And then you have to restart. Yeah, restart the processing sketch. There you go.
And in this window, this window is not scrolling with numbers. I'm only seeing the plot.
I wonder if it's that wave that everybody's, because everybody's kind of, no matter whether my hand over it or not, I wonder if that's the frequency of fluorescent lights.
It's the beat frequency of the lights. The background frequency, yeah. I've never seen the readout. Check this out. She's got one before.
Well, that's the name of her computer. Yeah, that's her profile name. Whiteboard, print, buffer intel, serial list. It has it. Print line. Put number 4 in just to see what happens. Because everybody else, Mac is 4. Ta-da!
Awesome, awesome.
That's what I did when I went to DU on Wednesday.
Yeah, this is what I did.
When you run a rectangle, so if I say I'm going to go to 200, 200, 300, and then I give it a width. And then the
It's
height-
from that point.
The height though is going down.
It is. It's over and down.
So I give it, I put it here and I say height 5, it's going to cause.
It's going to go down. Yep.
I believe you can give negative and it'll go up. Yeah, go ahead, put a negative. If you want it to go up from there, try negative. Yes. Because, did you put a delay, like I was showing people, because they wanted to be able to see it on the serial, the serial list?
I don't know. I haven't heard.
So it's flashing because of the frame rate. So if you drew the rectangle in the serial event, rather than the actual draw code. Yeah. So, but yeah, if you take the, because you'll find it towards the bottom, there's a serial event. All of this code, see where it says void serial event? If you got rid of all this, you know, not all of it, but the draw part of it, and you put, so see where it says the rectangle? You have it in there. Or is that, no, that's somebody else's? Okay.
They had it doing
Line. Try putting the background up in, no, because that up in the draw code.
So one of the things
So
that
no,
we'll
so
look at
yeah,
here.
because it's an event function, just like those key
You should write
press.
everything up. No, you just move the background, and then leave. You could try the rectangle in the draw too.
Exposition increments automatically, right? So every time we go through this, we add one to exposition. You can watch your graph build across the screen based on exposition. If exposition is equivalent to width, is greater than or equal to width, then exposition equals 0, which resets it back to the side. So we understand now how exposition is going. What we're actually doing is drawing a line on here. We've got a color, and that's that purple color right there. We've got a line that starts at exposition, goes to height, exposition to height, and then exposition height minus the invite. So it's coming up from the bottom. We're drawing a vertical line up from the bottom for this graph. One of the things we can do is take out all the line stuff. Here's why. We've done all this work up here in terms of identifying the port, taking the data that's coming in off the port, and that's what our string says. So we set up this string, a line, a bunch of characters. We said, look at this string. If there's anything there, if it's not null, trim this string. And we're going to take that trim string, put it into inByte, and this equals a float we're going to call inString. So inString up here is equivalent to now inByte. We're going to take inByte, we're going to map inByte from 0 to 1023. These are the numbers, the possible range of numbers coming in. We're going to map this to 0 to height, so we can get as big as the height of the screen. But we can take inByte and do something else with it. So we can use inByte. I can go in there and I can start at my if statement. I want to look up here and make sure, yep, I'm going to grab everything from here. I think what I'm going to do actually is start commenting. Forward, star, right here, and star.
What Jeff's doing is a multi-line comment. So instead of having to go through every line, it goes slash, 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 star, slash, or slash star to start it, and star slash stop.
So I just used that pairing thing. We got all these curly brackets going on here, and I figure this one opens, this one closes, this one opens, this one closes, and there should be, this one opens, this one closes, right? Anyways, I'm paired here and here because when I clicked on this curly bracket, it gives me this, which means I'm now on the outside of here. I want to make sure that I put this in the right place. Does this look right to you? Do I need to bump one more? I think I got to go up one line on that too. I'm guessing. No. So I'm going to move this up one line, backspace, boom, star, /.
You need to have the curly for
Yep, the whole event function. So all I'm going to do down here is I'm going to say rect. And in rect, I'm going to say, I keep grabbing the mouse. I'm just going to go 100, 100, and then I'm going to use in-byte as the size. And 100. So we should now have, I hope,
Just looking at the line.
so I now have a box that changes size based on the light coming into the light sensor. I can fill this with color.
Background functions and draw.
Yeah.
So notice that the draw function has nothing in it. Just like when we were doing the mouse drag function, there's nothing in, right now there's nothing in the draw. It's all happening inside this serial event function. And that's because we only want something to happen if there's information on our serial port.
It's right over the top of the serial event.
So we put it in, I guess
I'm going to put it in the serial event. Oh. There we go. So now as I get closer to the light,
Cool. Free swim?
free swim.
So everybody go jump in the deep end of the pool.
So,
So you guys have that folder in front of you with all those kind of projects. So we would say for the next, it's about 3:15 by now. You know, rest of the time, if you guys want to like start working on something, if you have a project in mind, you can start building, and we can kind of help and talk you through it if you want. If you want to do some of these projects, we didn't explore as a group video, but if you want to look at how the video library works, there's a video processing one in there. If you want to play around with image a little bit more, there's an image processing one. Since you have the Makey and we haven't gone back to it this afternoon, the processing the Makey, you actually build kind of a small maze game using the Makey to control a dot to go through the maze. So that is another option. So it gives you a little bit more project base and some more context to what we've been learning tonight.
But we're gonna stop shoving content at you. So
Because everybody's eyes.
that's a huge day.
Rolling back in the head.
I'd be interested in learning how to write data to a file.
Right, data to a
Into a
file.
table.
Create writer. So what I
Go for it.
there's a function called create writer. If you go to reference and put down create and put in create writer.
Mine too.
Okay.
If you have specific questions, let me know, but I'm gonna let you explore that. It's really simple. You create a text file in the data file for the sketch, and create writer populates that text file.
So for example, if I'm reading data from a sensor, I'm plotting it, and at the same time I want to push it to a file, I can do that.
Yep.
And then I could do it, I'd set it in a format, for example, so it's comment limited, and then I could read it right into Excel or whatever.
Exactly.
Okay.
So I'm writing so music is a music library. So you actually, similar to how you added an image or font, you use it's called the minim library. So if you go to sketch and import library, you can see minim right there. So it looks scary because it imports like 6 libraries, right? But when you look at the reference in minim on the processing website, you'll look at it and go, it's exactly, especially for the basics of just playing music and stopping music. So the stuff that you saw with the Makey and music is actually just pulling up like your GarageBand keyboard and playing around with the keys with Makey and the keyboard. If you want to do something with processing, like there's music playing and processing.
Assign a note to a
So that would be, again, you know, you can pull GarageBand, but you would also, I haven't played around with the minim. I'm actually creating content with the minim right now. Because it's a very complicated and large library, because it even's like synthesizer type stuff. But I'm looking at just the basic functionality for kids to get, you know, when I click here, it plays this song. When I click there, it stops the song. But it has the reference on its own website. But if you go to the processing website, libraries, and you'll find them. You get the basic structure of it, and it is just like I think it's minim, and then you create a name of the object, and then you load file, and you just add an MP3 file to your data folder and call it just like you would with MIDI. But Makey with the music stuff, you could play with Scratch. A lot of people do Scratch because that has built-in kind of musical instrument notes. It's okay. I mean, that's one of the easy ways because I can say. You know,
So, but we could make a tone and associate it with a specific.
Yeah, so like so Arduino, we have, this is actually a buzzer. So we can actually use this as a really horrible musical instrument. Because we can write a tone through the buzzer from a light sensor. But if you're just using processing, you can, I believe minim can generate a tone. Don't quote me on it, but that's where I'm working at right now. Kind of the edge of what I'm doing. Because what I'm working on is taking and building these sheets for the basic structure of processing. So all of the libraries, they come with processing, and then go beyond that. So you have, like, if you want to get into map applications, here's the library that I would recommend. If you want to get into this, here's this one.
Oh my God.
Kind of all these different things.
I'm trying to make the.
We are first row this.
so cute.
This is awesome.
Oh, wow.
So yes, everybody come over.
Everybody come over here, exactly. I'm so impressed.
My degree in animation up there. There's a certain amount of things that you have to sell into each thing. Does it just need a certain amount to really have that kind of thing? Or you can do just a little, just a little bit, just over it. Just because I noticed you had quite a bit, just to give them how much. Okay. I think you can just literally get a piece of wood and get it. Yeah, oh yeah, okay. So that's just the, okay, target, yeah.
Did you do the pineapple and just basic processing shapes?
Yeah. So when we were doing the shape stuff, I was like, oh, this pineapple is so crazy.
That's cool.
Very cool.
That's, you think that beats
Oh,
the hippo?
that beats the hippo. Well, the hippo didn't have any physical.
No. This would be the next one.
You just need to go buy a hippo then.
Do you have the hippo on your machine?
Oh, it's on my desktop. But
It's on my Mac. I'll plug my Mac in. I have to show you, we have to show you this, as long as we're looking at cool stuff that people built in processing. I was in New York about 10 days ago, doing some work with New York public schools, and I was at a classroom in Manhattan, and this teacher said to me, you have to see what my student did. And this kid pulled up this processing sketch, and I hope to God this is it.
But I want to build this so
Uh,
that I can really do makey.
What did I search for? Student.
Go back. No. Hang on.
You want to just?
Did you find it?
No.
I'm gonna mail it to you. Yeah.
I'm just not entirely comfortable searching my email on the internet.
Got it.
Yeah, it doesn't. Hey Jeff, how many outputs on the Makey Makey?
Well, there's one output really, but inputs there are like 20.
So funny thing happens because when we are in the office, like we build dashboards and kind of computer vision stuff. But the things that fascinate us the most are like these things that students create in a matter of like 50 minutes.
From a kid in a class today is the name of it. Capital F, from a kid in a class today. It says run this. second one down.
So, Jeff, tell us about this kid. How long did it take him to make this?
I have no idea. I showed up. They haven't been working on processing all that long, maybe a week. And he shows me. He goes, "I want to show you my sketch," and then he opens this thing up and. And the eyes.
How old? What age?
12. Seriously. At the computer school, like across the street from the Museum of Natural History. This 12-year-old kid.
The cool thing is if you can like deconstruct a hippo. I want to like connect this to the Hungry Hippos game.
I want this to be projected on the side of our building. 3 stories tall, and you walk by and it goes.
Follows you with its eyes. Yeah, I explore the hot sheets. Check out the video one, especially because I noticed all of you have Macs, which have built-in webcams. And the examples in the video library are really cool ones. They get super creative with digitizing you matrix style. So they use characters as, the density of characters as how they show the image. Single line image scan, which is kind of kooky.
So Derek, I have two questions.
Yes.
So the first one was, did you say you could export these as Java?
So these are, right here, we're in Java mode, and I can, when I click on export application, it's going to ask me to save it. I'm just going to hit OK for now. And I need to save this, so I'm just going to say test. And it's going to ask me if I want, so this is just exporting an executable before, so I can't remember what, so this is like, it's going to create an actual executable, like run this file. And I can option out so that it's automatically going to open in full screen mode. So if your window is only so big, but it'll actually have a gray background around it. But it actually takes all of the libraries with it. So you can create an application that's reading a serial port. And so you don't have to do a lot of this serial setup stuff. Sad thing is it does, every computer's different with its serial setup. So the only time I really use an executable is that if I know that it's going to be residing on a machine that I know what the serial setup's going to be like and things like that.
Next question.
Yeah.
So can I create my own functions? And just drag them, I just buy function name and drag them.
Yep. So you can create a void function and then you add what that function is.
Return type is F3 or
Nope. You can return type.
Another question? So we're looking at the graphics and you can go into the objects graph and say, I want to look at it from the top, I want to look at it from the side. Some graphics software lets you leave the objects in place so you can do viewpoint. Can you do that?
Yeah. So
I'll just go look at it.
yep. So look at the 3D stuff. There's a 3-dimension. So if you go to the processing website, instead of reference, go to examples or tutorials. There's a whole 3D section of tutorials in there. that you can change viewpoints, and then you can also rotate the object itself.
I think there's.
You can move a light source around. I mean, it's pretty.
That was another question.
I think in.
You can apply an image as a skin, so you can. One of their examples, they take a flattened map of the globe, and they actually apply it to a sphere, and then they apply a light source to it. So as this thing rotates, it looks like it's the Earth rotating.
That's an example.
Yeah, I'm looking in the examples under 3D. There's a camera one, I think.
So if you guys look at the tutorials options, we've pretty much gone through all of this stuff except for P-shape, some shaders. There's a lot of this advanced stuff. But if you go to the P3D tutorial, it tells you about the 3 dimensions, how Z increases away from you, how you can lean. So like normally we're looking at a square this way, we can actually lean that square, rotate it on its Z-axis. So here's that globe example, so a textured sphere.
So there's in examples under 3D, there's an example called perspective. If you look at camera, there's one called perspective and a file called camera.
It's under examples and then what?
3D.
I'm not seeing that. I must be clicking.
You gotta scroll down on the sidebar. It's kind of down at the bottom.
So it's basic camera perspective. So you move left and right, zooms in and out, and then up and down rotates the shapes.
Is processing work on iPads? That's
Nothing works on it.
You mean in terms of exporting something to it? Right now, the only thing that it works with, that I know of, is with an Android device.
I think,
Is that easy? Is that a quick thing to go through?
No, I'm just, because I'm on my laptop, so like I clicked up here and you can see that I have Android mode, as well as a couple other modes.
I've got an invitation to add a mode.
Yeah. So the install process, if you, here, I'm gonna, So if you go to processing.org, Processing's website, and you go to tutorials. Is it in Android mode down here? It used to be on here. They moved it. It used to be here. That's okay. We can just search Android. So right here we have kind of the tutorial, takes you through installing the development kit, everything like that. The wiki for this is really good. I have a lot bigger success running it on an actual device than using the emulator that they say to use. So it's tutorial/Android, even though it doesn't show up on the tutorials page anymore. And then I'd follow it just basically gives you the step-by-step of installing the SDK. And the great thing about the Android's website, the developer website, it actually reads what operating system you're using, so you don't have to, you basically say install or download and install, and it'll read that you have a Mac, and then go from there. So it gets you the appropriate software pretty quickly, and all that fun stuff. The tool chain, you want to use, I'll get you a handout. I've been starting to do the handouts for Android. I'll get you the first one at least, because that, yeah. No, it's exactly what I'm looking for, because it's, I've been trying to do it multi-platform, but if you're trying to keep it one sheet or so, it's hard to do.
That's the way I always do it. Well, I mean, same thing. Yeah. All USB is a way of configuring the electrical lines so that I can push two streams of data at the same time. But then when it comes out of the hub, it's serial. When it goes back in, it gets reassembled into serial. USB is just a way of moving more data faster. So
I was just making sure I wasn't overlooking, there's no other technique that I would need to.
Well, I mean, the other thing you could use is Bluetooth, but
That's just a wireless serial.
Just a wireless serial port.
Yeah. Same with XP.
Yeah, same with XP. And that's all I'm doing with the XPs is plugging in an XP unit and pulling stuff serially through the port.
So for example, on my dress stand, right now I'm running a long USB cable. I could just put an XP module
And send wireless data.
and then just have a battery, so it's totally portable.
Yep.
I set it out there so I don't blow myself up.
Right.
Sit back at behind the glass shield.
Yeah.
And initiate launch and read my data.
Yep.
And right off the dress stand.
And with if you put a USB on it, if you put an XP on it, you can control everything wirelessly. You don't even need to run a line out there. You can set an Arduino up on there to run the ignition sequence, the data logging, the fire extinguisher, it doesn't matter. You can,
The XP, I took the class here a few years ago. As I recall, once you configure them in the simplest mode, it's you pull a pin high on this and the pin goes high on this.
That's right.
You want to use it for a push button remote to.
Yep.
To
And you can get,
control a relay.
actually you can get analog data pin to pin on. You don't even need a controller out there. You can configure the series ones for to read analog data.
So I could have my analog data and my digital pin mapping.
Off
And
nothing
not
but,
have the Arduino
not even
sensors
have an
out.
Arduino.
Well, I need in the house at some point, right?
Right.
Oh, no, I wouldn't, because you've got the little, wait a minute.
Once you power the XP, yeah,
you don't need that.
that's right.
And that will
So,
go into the available on the server as well, right?
so if you take,
I'm not gonna do series one.
yeah,
the
series one is the one
whatever it's going to do.
yeah, the breakout work, this is what we're doing. So once you plug in this, you just get this 3.3 volts in ground. That's yep. So that's gonna go to the computer.
Yeah, this is gonna take it depends quite a while.
So if I
And especially downloading or guest Wi-Fi is kind of.
that and then I'll find the tape thing.
I know, right?
I'll read you these right there, if I have any questions. So I could build a sample, connect it to, to do it up cable.
So,
Yeah, it doesn't take any, just one single chip to charge your phone.
Then when I'm done, we'll leave the app on this one.
So that's why I have to go, periodically I have to go through my phone and like toss a lot of like test apps.
So, when I was in
whatever you put on as a write on here, you'll configure a read on the one that's on there, and then.
I never really seen an ADHD app. Is there anything like?
So if this was so if you took our command.
No, not completely sure I could answer that, but it's a,
This is
it's a
just
quick
gonna
question.
Yeah.
Yep.
What I would
I'm
do
like,
is I would.
you know, it's one of those things where I'm like, hey, I want to use Google Maps and processing. Google Maps processing library, and it just brings it in.
Just take one of those.
I don't know this.
In order, you need an analog to digital converter. In order, right, in order to write this to a memory. Yeah, oh, I can, but then nothing converts that into a digital stream on the computer, and that's where these are used.
Interesting. Take a look at it.
So you're sending analog down, right? Yep. So, yep, exactly. So then you're just reading whatever this pin is, just configure this pin. Yep. And then all your, you can do
I'm
all
really
your
trying to
control
get it.
stuff from here.
And this fun thing is now that I have, there's a SparkFun email address behind me. When I go poking around and go, hey, you know what, it'd be really cool if your library worked with Android mode. People start responding. Well, just saying, you know, I'm always from SparkFun. Whereas when I was at a K-12 educator license, you know, email address is like, this is a middle school teacher asking me. So it's been interesting to kind of the community and being like, hey, I want to be able to
With an oxidizer.
use these, yes. So if you're not playing with these guys during free swim, we prefer to get them back from you. I know that you have your USB cables, but we'll snag the Arduinos. They are.
Test them. I did the exact same
They
impulse.
like have something I want to say.
The original.
I'm so used to looking at the catalog
The
with
difference
employee
is I'm not
pricing.
loading a injection program. So I'm using computerized, activity control injection.
Yes,
You gotta have
100% this.
additional stuff with numbers that's not, it's gotta be lightweight.
Nope, not anymore.
Uses a little, concepts that,
Yeah. These, this is what we're using on the lens.
it's actually, we don't sell them, we always sell a new version, which I have to go over, but I think it's almost identical. That's temperature, pressure, relative pneumatic. Yeah, I've gotten the triple axes, monotonic. So I'm familiar with the breakouts, I just haven't used this particular one.
So, these are good, these are really good. And I like.
And before any of you sneak out, we also have these. So these are just quick feedback form on the class.
How close is
So
that?
if you can fill it out for me, it'd be great. So we have the wonderful QR code if you're a phone person, but we also have the URL as well. So before you leave, sometime before you leave, if you can fill it
So
out,
are the
it'd be
registers different?
really
Is the
helpful
register
to
right
us.
different?
No, it should be completely software compatible.
It's drop-in compatible with the BMP code.
Not footprint, but software-wise, yes.
So like all the builder stuff, all gym stuff, that all,
It should all work.
well, I need to test that. That's good because the balloon projects are all documented.
Yeah. Let me know if you find any differences.
I have to test
They
it.
claim that it's all software
Okay,
compatible.
okay, cool, very cool. They came back, they wanted $10,000 to go through the catalog,
Yep.
pick a central. So that was like on Wednesday. I ordered the breakout board for your triple axis management. And got it like the next day.
Sure.
And then by Friday, I was illustrating to them with a nail, it was just like covering it over. I got the magnet on, and I was holding this thing and showing Claudia the values on the screen. So I said, yeah, I think it might be possible, you know, to do what we want to do. And so kind of push really back, and I guess that's at the point where we have to talk to the engineers from that. We don't understand this stuff, kind of, and the quotes were getting too high at this stage. So,
workshop.
ordered the raw chips now, made some custom boards, made a drill guide in this little tiny.
Oh, go to, there you go, and then hit done.
Devices, I could get it right in the nose of this building. And with custom circuit board back with a full micro. With custom USB port on the side with the road, because they want to have the plug-in port for it, right?
Right.
So I made a custom 4K connector.
Yeah.
And this thing will come finished, ready to go, so in 2 weeks. So that's, you know, this maker stuff, that's cool. I'm showing this to you guys. Where'd that come from?
Right.
And the housing.
Yeah.
Painted it, I did some custom graphics in Illustrator, laminated them on there, had an LED bar graph out here, and targets in, targeting, around the axis, you know. And the guy, and we were hitting this man spot on, that's, every time, it's buried in bone, I mean, you can't see it, it's a blind drill located, and they were just blowing away.
Right, right.
But the technology is to transform.
Yeah.
This for the little hobby interest.
My son, like yours, just pushed out of high school a year early. Yesterday.
This is the Windows version.
He's going to college, but he's trying to pay for it by writing code.
So what we're doing though is just getting the development kit from this set of tools, and then we'll use it in the process. So for Apple, we're back. I'm not so sure if there's install. So if you go to processor,
Yeah.
click on this drop down, go to add mode, and then select Android. Install. And then it'll ask you to.
Are you serious?
Please, it'll ask you to point to where your SDK folder is. So then just follow right.
Is that
Android, you start processing before it's installed. Okay.
But, there's my age, that's
Yeah. It's everywhere.
Reopen the process.
I was just wondering.
Oh, right.
Yeah. I just pulled it in.
Oh.
Yes. Then go track down. So you want the SDK folder that you remember we had clips versus SDK. There you go. Now you're in Android mode. So it says Android, and then this header changes. You notice it visually changes.
So I have now just managed steps 1 and 2. Well, that's pretty cool. What about the tool change?
So processing Android, and you want SDK manager. So then you can follow which ones. It'll tell you basically which version of Android, because you actually have to downgrade a little. So it has nothing to really do with your phone, but it's just in terms of the maximum ability to, because everything's backwards compatible in Android, but so like API, I think 18. If you go higher than that, it gets all funky and wonky. So we just always work with that API version. And then, perfect. I saw, well, I'm with the sounds now. Did you add the like minim library stuff?
Yeah, so.
I played around with it. I mean, it's not.
It's like, it keeps
So,
like triggering it to play.
Yeah, this one there is not me. He is one of our founding members. But Hyperspace. There's also one in Solid State.
Isn't that awesome?
There's 2 in Denver.
What is the order called?
Solid State Depot.
So,
And there are delay function.
Yeah, it's too
2 in Denver and
But when I put this
delay is not a recognized command.
Oh, are you using it as a key press function? In the key press function? Yeah, because it doesn't recognize the normal Arduino delay.
yeah, I haven't been to another one yet.
The hard part.
My understanding is it's very
So,
much
online,
is a lot less.
it doesn't read, and can until afterwards. So,
wider range.
Millies.
So that might be a contributing factor.
So you're gonna store,
But there are actually 5
you're
totals.
gonna store
in Denver, Mexico.
start time. You're gonna create 2 variables. Start time and current time. Here we go. Let me see if I can write this out, because I gotta think about it. I'm gonna create 2 integer variables called start time and current time. So let me see, can I do this? Oh, this is, I hate this. You're using key press?
Yeah.
If key press.
Sounds good. You know, there's to be a big issue too today.
I can get these very easily.
Are they on the website? No. So they're
kind of restructuring the curriculum of Runberg.
Okay.
And they'll be on it. They're maybe just a little bit of time because they're still waiting for it.
So just shoot me an email.
They're in Google Doc right now.
Okay, I can just forward that. Sounds good. Sure.
Cool.
No, I'm actually an electrical engineer, so I work on it at Runberg. Like this is portrait to the hackerspace. There are actually two in the Denver area. There is Den Hack off of Highway 58 and 95. There's also the Calgary, which is off of, I think it's Evans and Broadway.
Yeah, it's out in the Bronx.
Closest one to you. It's a little bit of ways away, but you can go visit.
There's also a bunch of stuff going on in the libraries. So I think Jefferson Public Library is good. So my Belmar,
Yes.
Belmar's doing hacker stuff.
So what I normally do is take 18 and everything to 11.
Yeah.
I recommend
Take
taking
them all, then you're
first
doing
things
something.
Google Driver.
Tinker Mill.
Yes, I actually have parts. They're not mine, but they are in the space.
Awesome. That'd be great. Thank you. Appreciate that.
I know.
Yeah.
It does
You
push
were
down.
into that.
And should I uncheck all the ones
Yeah,
that?
it's off of Evans and Broadway.
So uncheck.
It's actually
Everything, so like 18
that you can go ahead and read, because it's one of those things where you, some random function will have
A connection to some kind of API.
Yeah.
I see 18.
I will possibly recommend it's not as well, it's social media very well recently, so it's an
I'm gonna come around so I'm not gonna hear you upside down.
If you want to go and
Oh, I was impressed if it's.
do something like
Yeah,
that,
upside
but
down.
it's kind of
They were displayed.
dirty, it's kind of embarrassing, a lot of I've heard good things about the concrete, have not been
So
out
there's
there.
APIs.
Started it. My understanding is concrete is a store front that has a bunch of this kind of stuff, and then also a hackerspace. It usually does both.
So I would just click on the big box.
Go to the website, there's a bunch of classes. We'll be teaching this class, there's one in James.
And then that's the thing too, if you ever,
Which is an audience.
if you ever published an app using processing, which you can, then it's applicable with all of those APIs too, so it's not a big deal. What's
The
up?
reason I'll be taking that is so I can turn around and teach on the weekends.
Okay.
at Tinker.
Okay.
So right now we're in a lull. You know,
This is
much
conference
less
laptop.
but we're very active. In fact, I was there last night and there was 10 people there. Our goal is to get wow. We usually have.
Storage is not a problem.
We
All right,
actually
let's do it quickly. Okay.
Please go check it out.
Yeah, absolutely. Thank you.
There's that one.
Would they have something like
Oh,
that?
there is like-
We've got 3 3D printers. Small
So what I would do
We
is,
have multi copies have
Yep.
Chinese on top of the bigger one of the little extruders, and then you have a big one that's a Delta printer. So instead of the head going forward, back, and left, right,
Right.
it's got 3 arms, floats around, so it's a Delta.
so that those USB drivers are probably the most important of all of these.
We have 3D printers, we have a laser cutter.
Cool.
There's also currently
So install these, and then it'll ask you, if you look up, you have 19 installed. So after those all installed, then you're going to select 19 and it'll ask you, you can then uninstall it.
Like that. So that's the process of being ordered.
And then you go through, you have to go through and select accept your accept license. Just go over and select. So select the top, if you select the top one. So not the triangle, but the text.
Also, how to do about Hackaday.
Yes, if you click on anything with a green check, red X, you have to accept the.
There's a whole lot of articles that come through, and a lot of them are readings or just.
I think it's just one per API that kind of.
You have to across there, like tutorials on how to make things in programs that you can preprint. They also
Yeah,
have-
are you familiar with
so they have
Linux installers?
Blender, SketchUp, OpenSCAD, AutoCAD, they've got all of their tutorials on there. They also have how to take it from this picture in program and actually make a font out of it. So they have tutorials
Cool.
very
Install.
there's a lot of
There you go. So it'll take a little bit of time, obviously. It's like 10 APIs in here.
Okay, it's not very, I'm still on two.
So then you're
They
uninstall 19.
themselves, but really don't do a whole lot. Yes, Thursday nights, they call it Interview Rooms.
But you would have, I mean, looking at the wiki, when you look at the instruction set on the wiki, it's a really good wiki.
Getting it to flip over.
So it's actually maintained by it's by process people. There's a subset of kind of these process people who have a invested interest in Android doing it in process.
Like, you guys got some really cool stuff. Matt's doing swarm robots.
Especially within the hobbyist realm. I mean, you start looking and you go, I can write my own apps. Can I write my own apps? And I go, well, I have to learn AppleScript. You know, and then you can start. So BeagleBone Black, you can install Android on. So that's kind of it's like an Arduino drugs. It's a much more BeagleBone Black. It's an ARM Cortex chip.
He's been so good to me through the years. He gave me grad students.
And
that's why I'm so world.
there's
So
another board that'll run Android as well. So then you're just like, I can write apps for that board, interact with the hardware. And in terms of a development, or you're just developing for, you're taking a phone OS and applying it to embedded systems. Perfect. So this is a 320, this is a 328U4. So it's the same, yeah, it's the same as the Leonardo. So you can take this code and run a Leonardo on a Leonardo. Yeah.
So if I wanted to give this functionality,
Well, and with the number of pins you have on a Leonardo, it actually expands if you want.
And in the next week or so, it'll be 4 or 5 my Facebook page.
So any of the,
Now, taking website. Last week we shot a video.
I don't even think there's any Arduinos that are YouTube. Their main chip is YouTube. The Uno is the part of FTDI. Yes, they use YouTube as the serial communication, and then the U4 is the big processor.
is there plenty of clock cycles left over for running code for the next cycle?
Yeah, you're good to go. I mean, it's depending on what you wanted to do. I mean, if you're just using it kind of like as that keyboard breakout, I mean, there's plenty of stuff.
Because I see the chip manufacturer selling this specific chips. And I thought it was just one of the hardware part. I expected to see that chip.
So yeah, it just uses the capacitive CapSense library for Arduino. Would be a good choice if you're wanting to kind of expand on this. I actually created, so these hot sheets, these are processing ones. I've also created a bunch of Arduino ones that you create. I took the scale for a piano and you make a CapSense piano using some copper tape and a mega ohm resistor and the CapSense library.
This was very good. Cool. What I hope to do out of class like this is, what's the role of maybe my one little thing that goes box and then the rest of it.
Yeah.
It's a little overwhelming sometimes when you.
Whole day of dump.
No, without that.
Oh, yeah.
Just say, I think I'll run processing this week. But I can leave it and just see it.
And one of those things too is like, you know, you pick up one of these kind of self-learn bugs, that curve becomes so steep. You know, you get to the third chapter and you're like, what happened? Like, it's just so steep. So that was one of the reasons why we developed these worksheets, is that it's just a very small increment in a flow that makes sense. Yeah. No problem. Yeah, same one, but I haven't put the same one.
Yeah, because I did it before. I did this at cases. I've written this before. I got it.
Let me know. Send it to me when you get it done.
Yep, which means the library is not installed. So this goes into a folder in your documents. So in processing, we have a folder called libraries. So it goes in there.
So here's 6 of them. And then
Yes.
the code is 4.
Yep.
Okay, so code is
You can
space.
code, click, space.
So that would give you this one.
Copy and replace.
Okay. So it's just a matter of figuring out how to assign. So could I do?
That's the one